Welcome everybody to the Takeoff RAG course. So in this course, we are going to be teaching you how to use retrieval techniques with AI models. So let's go ahead and start jumping right into this. First, I want to talk about a couple of the prerequisites to make sure that you can get the most out of this course and follow along with everything that we're going to be doing here. So number one is you will need some basic coding skills. If you're familiar with the platform, you're probably good to go. If you've been able to follow everything else so far, you don't need much. And if you don't have any coding skills, definitely use a tool like Cursor. We obviously have our very popular Cursor course, so go check that out. The great thing about all of these AI tools is that if you've never written code for the first time or anything like that, it's super easy to get started. So you will need to be able to write some code to follow along here, but nothing too crazy. You will need an OpenAI account. So we're going to be using OpenAI's GPT-4o Mini quite often in this course to use a really nice cheap model. You're going to need the API key to be able to access their API and use things like their embeddings models. So you're going to want to make sure you go sign up for an OpenAI account if you do not already have one. And we also recommend signing up for a Supabase account. So worth noting on costs, just really quickly, a few dollars is great. If you have, even $1 or $2 in your OpenAI account, you're going to have plenty of credits. We're not going to be just burning through a ton of API credits. Supabase, you can sign up for their free plan. Everything that we're going to be doing here is something that you can use on the vector database side for free on Supabase, so you won't actually need to upgrade to a pro plan at all there. So the only money you will potentially need to spend is a little bit on API credits via OpenAI. But if you are comfortable using some sort of free model that's out there, feel free to use that as well. But we're going to be using OpenAI models for the most part. We'll be doing a little bit of Cohere models if you want to get into some of the advanced stuff. So if you've heard of Cohere, we're going to be using some of their Reranking APIs to do some advanced retrieval techniques later on in the course. So if you really want to get deep, I also recommend a Cohere account, but these kind of are the core three things you really just need to worry about. So that being said, let's actually jump into what the goal of this course is. Okay. So by the end of this, we want to make sure that you feel comfortable building a complete end-to-end RAG system in a real-world project. So whether you're going to be doing things like building internal tools for your company to help you run your business better, you want to just build personal projects just because you've gotten into being an AI engineer and you kind of want to get a better feel for things, whether you have clients that are expecting you to build projects and actually deliver these kind of real-world retrieval systems. The goal is by the end of this, you'll know all of the moving parts, you'll know how they all work together, and you'll feel comfortable actually going out into the world and building these tools. So why do you need to learn RAG? So RAG is really essential. It's one of those fundamental pieces of AI tool building that it's just really hard to proceed and build really high quality tools, really useful tools, if you don't know how to build retrieval systems. So RAG, if you are not familiar, stands for Retrieval Augmented Generation. It is basically the process of giving an LLM, giving a large language model, an AI model, additional information, whether it's from a knowledge base, whether it's from real-time information on the internet, so that the LLM can provide answers based on specific pieces of context. So this comes in handy in all sorts of places, right? So some common RAG examples are, using LLMs in conjunction with a knowledge base, right? So say you have, hundreds, thousands even of Google Docs, maybe in your own personal library, maybe it's in your entire company, and say somebody has a question about some sort of HR policy, and maybe that's documented in a Google Doc. Well, you would want a RAG system to be able to go fetch based on the user's query, right? Let's assume you're working in some sort of company chatbot or something like that. And, one of your employees says, hey, what's our PTO policy? Well, what you want your RAG system to do is go find in all of those documents the most relevant document so that it can add it into its context so that when you hit that API, and you're actually getting the answer back from the LLM from one of these AI labs, it can actually have the relevant context that it needs to answer a question, right? So knowledge base answer Q&A is kind of one of those really popular use cases you're going to see. Another use case we see a lot is fetching something like critical business information for internal tooling. So maybe this is customer data, sales data, right? Say you're building like a customer support agent, right? Well, one of the things that you're going to need is when say a customer says, hey, I want to upgrade from a monthly plan to an annual plan or something. Well, you're going to need to be able to fetch the live data from, Stripe or something. And you're going to need RAG in order to do that, right? Another popular use case, accessing up-to-date live sources on the internet, right? So this is good for things like weather, things like stock information, right? If you ask ChatGPT, for example, what's the stock price of Apple, it's not going to know, right? It's not in its training data. OpenAI, obviously, if you've used ChatGPT lately, has some sort of web surf capabilities. And what OpenAI is doing kind of in the background is they have a retrieval system that's fetching that up-to-date information from the internet to help answer that question, right? So getting live data is a great use case for RAG. And kind of the final really, really core common example is using RAG as a long-term memory system for agentic workflows. So that's a little bit more complex. We'll kind of more focus on these three here. In our agents course, we'll probably hit the memory stuff for agents a little bit more. But this is kind of some of the main use cases of RAG that you see. Obviously, one of the more popular products out there that exists that uses a really sophisticated retrieval system is Perplexity. So Perplexity is, kind of the AI Google, if you will, where you ask a question and instead of just getting you a bunch of links, it uses links to actually generate an AI, get an AI generated answer, right? So in this case, you see here, I have an example where we ask, what is the price of NVIDIA here? And you can see what they're doing is they're grabbing live sources from the information, from the internet, right? So they're kind of doing this thing right here. And they're using that to get you the most accurate data and supplementing that with an AI generated answer, which is below this graph. I probably should have included that here. But I think you kind of get the picture, right? So you have these really huge billion-dollar companies that are building super advanced retrieval systems. And if you want to build really great AI products and tools, learning how to build out these systems is pretty critical, right? So let's talk about the outline of the course really quick before we kind of get into actually learning all this stuff. So we've sort of organized things into three parts. These are kind of the core three parts, and then we may have a fourth section with some sort of one-off videos for those of you who want a few extra resources that are a little bit more scattered. But the core three sections are going to be learning the basics. Okay, so we're going to learn about embeddings, vector databases, similarity search. We're also going to be learning about kind of just some basic prompting techniques to help get the most out of your kind of RAG-related AI queries. Okay, so all of those basics are sort of, when you see a product like Perplexity, all of these things are coming into play, right? And so learning how each one of those pieces kind of fits into the puzzle is really important. What we're going to do in section 2 is we're going to actually create a full end-to-end RAG system. Okay, so this is going to be more of a back-end focused thing where we're going to just try and take a very basic idea here and write the code from scratch. Okay, so we're going to do a lot of writing code here in section 2 and in section 3. And in section 1, we're going to focus more on conceptual things and just explaining code that I've already written here to just drive home the points. In section 3, we're going to build a full real-world retrieval project here. So we're going to kind of take everything that we've learned from these first two systems here. We're going to just build kind of a basic tool with an actual UI, with an actual app that integrates with a RAG system that we're going to build. Okay, so by the end of this, you should be able to build any kind of RAG system, any tool that you have, whether that's for yourself, for your business, for a client, what have you. We're going to make sure that you learn everything that you need to actually go out and build all of these really cool retrieval systems, because once you learn how to build retrieval systems, it really raises the ceiling of your kind of experience as an AI engineer and as somebody who's kind of has the ability to go out and execute on some of these product ideas. So that being said, let's go ahead and get started and learn the basics. In this section, we're going to cover embeddings. We're going to cover vector databases, which is how you can actually store your content with the embedded numbers, how we can perform similarity search on our vector databases in order to retrieve the most relevant information based on a given query, and some prompting tricks that you can use to help get a little bit more out of your retrieval systems. Okay, so let's just go ahead and do a little brief overview on RAG. I know I touched on this a little bit already, but just kind of really want to make sure that everybody understands what RAG is and why retrieval systems are so important in the context of building AI applications. So again, RAG is just a fancy acronym that stands for Retrieval Augmented Generation. You'll often hear me in this course use either RAG or Retrieval. My personal preference is actually I just like retrieval systems better than the term RAG. I think RAG is like a little bit kind of, I think when you start introducing a bunch of acronyms into things, it just makes it more confusing for people. You know, a lot of researchers like it, which is obviously where it kind of originated from. Retrieval, right? If I say, hey, we're doing document retrieval, I think for the average person, that's just much more clear. So you'll hear me use retrieval interchangeably with RAG pretty frequently throughout this course. And a retrieval system is just trying to augment your large language models. Okay, so if you're making a call to, GPT-4o, for example, maybe you're using Claude 3.5 Sonnet as your model. What you're trying to do with a retrieval system is you're trying to access additional information from external sources, inject that into your query so that you can get a better, more detailed answer that is supplemented with information that is relevant to whatever your query is. Okay. Right. So we've covered some of the real-time examples in the previous section, but a great use case for RAG, for example, is answering questions based on real-time weather data. Why is that? Well, if a model that was trained a year ago gets asked the question about the weather today, right, it's obviously not going to be able to give you an accurate answer, right? You're going to need to supplement that LLM with additional information, right? And so that's kind of the whole premise of retrieval systems. Okay, so what problems does RAG solve? Okay, number one is going to be accuracy and reliability, right? One of the issues with large language models is hallucinations, right? Sometimes it can confidently give you an answer to something that is very clearly wrong, right? Maybe, for example, if you asked a model, what's the capital of France, and it, say it gave you the answer London, obviously that is wrong. That is what we would refer to as a hallucination. Something that simple, the models these days are going to get right. But the point kind of stands, which is that maybe you want to, instead of just having the AI model directly give you the answer, maybe you want to supplement the prompt that you give it with a little bit more information, right? Maybe you go fetch, you have some sort of RAG system that based on the country that you give it will actually fetch the correct answer for its capital, right? And so that would be an example of using a RAG system to reduce hallucinations, right? So, another example we've referred to the stock information, right? Up-to-date financial information, up-to-date weather data, right? Using up-to-date data is something that can really power incredible products like Perplexity, like GPT web search, things like that. So if you need access to the most up-to-date information possible, right? Say you're asking a question about, what's the score of an NBA game, right? Maybe you want to know what's the score of the Warriors tonight, right? You're going to need a RAG system to actually go fetch that information, right? Another one would be fact checking, so maybe you want to, ask a question based on, a scientific paper or something. Well, what you could do is you could go use a retrieval system to check the answer that the model gives you based on some sort of reference documentation, right? So the nice thing about RAG systems is you can really boost the accuracy and reliability of your answers by supplementing your prompts with additional external information, okay? This is kind of the same side, two sides of the same coin, which is knowledge enhancement, right? So this is things like accessing your proprietary data, right? So say you're building internal tooling for your company, maybe you have some sort of CRM that's internal to all of your team members. Maybe you want to build an AI tool where you can kind of in a chat interface really quickly get information from that. So that would be a good example of like accessing proprietary data with a retrieval system. Okay, you can combine multiple sources of data. which is really cool. Maybe you have a bunch of PDFs that are saved and you want to combine those with, some Notion pages. Maybe you use company wikis in Notion or something, right? And so you can start to kind of mix and match all of these different sources together, which brings me to the third point here, which is you can also build multimodal retrieval systems, right? So maybe not only do you have a bunch of text documents, but you also have, a bunch of images, right? And you can kind of, maybe you have a bunch of diagrams, say, you have some sort of tool that's reporting on your last quarter sales numbers or something, right? And maybe you have a couple charts in there that you want included, and that's kind of more image based as opposed to text. So what you can do is you can kind of combine all those different pieces of data, right? Eventually we're going to get to things like video, we're going to get to things like audio, which is kind of already starting to happen, right? So you can kind of mix and match all of not just the sources of the data, but the actual kind of data types itself, right? And the third thing that retrieval systems are really useful for is cost and efficiency. Okay, so the LLM models are getting context windows that are longer and longer and longer, which means that in the prompts, in the conversation history, right, you're able to kind of cram more information into those requests. But if you kind of maximize the context window, those requests are going to be a little bit more expensive. They're going to be a little bit slower. So by using retrieval mechanisms, you can do things like, instead of including 50 documents into something, you can actually just go grab, the 5 most relevant documents, and reduce your costs by 10x, get faster response time. So depending on what you're trying to build and how you're trying to manage your costs and your latency and things like that, RAG systems can really be a benefit there. Okay, so just to drill a little bit more on the context window point that I just made, let me first just kind of explain, if you are not familiar for some reason with what context windows are, the idea of a context window, right? So right here, we're just on OpenAI's model page here, and we're looking at their GPT-4o model, which you can see its context window is 128,000 tokens. So for some brief history here, when GPT-4 originally came out, I believe the context window was 4 or 8,000 tokens. I can't remember which one it was, right? But it was basically, significantly smaller than what it is today, right? So now, a year and a half later, when we have GPT-4o, now we have 128,000 tokens of context. So what that means is we can put more text, more images in those requests to these AI models, which means that we have the ability to, I believe, I want to say the entire Harry Potter series or something like that is about 100,000 tokens, something ballpark in that range. I may have the exact numbers wrong on that. But the point is, a year and a half ago, you could maybe fit one book in, and now you can fit a whole series, right? And so going forward into the future, these context windows are going to continue to grow and grow and grow. And so one of the things that you hear people debate is RAG dead? Do context windows, as they get to, for example, the Google Gemini models have million token context windows already, right? What happens when these things get to 10 million, 100 million, a billion, right? Does RAG even have a purpose? And my answer to that is RAG works in conjunction with context windows. It's not an either or scenario, right? RAG, because of all of these reasons that we listed here, right? Accuracy and reliability, knowledge enhancement, cost and efficiency, RAG is still going to be something that continues to matter in the future. Okay. So if you hear people saying, hey, context windows are growing, you're not going to have to worry about RAG anymore, my answer to that is that's just fundamentally not true. Anybody in the real world that's actually building out these systems and building these products, RAG is a very critical piece of their infrastructure. So context windows give you the ability to fill, basically use more memory in an AI request, which is great, right? We want bigger context windows, but we also want the ability to continue to build retrieval systems so that we can utilize as much or as little of that context window and have ultimate flexibility in how we manage that context window as possible, right? So RAG in a lot of ways is a way to sort of manage the usefulness and the efficiency of context windows, okay? So let's just run through before we start getting into each one of these particular pieces, kind of at the individual level. Let's just kind of go over a quick overview of the system as a whole, just to kind of give you a little better feel for the process that we're going to be exploring in the coming lessons here. Okay, so the way that retrieval systems work is you want to enter a user query. Okay, so in this case, imagine we have a chatbot that answers questions based on Wikipedia pages or something like that. Okay. So let's say a user asks, what year was the Hubble Space Telescope launched? Okay. So on the user side of things, they enter the query. A bunch of stuff happens on the back end that we build for them. They don't need to worry about. Their query gets supplemented with whatever kind of the output of that system is here. And then it uses the query with kind of the relevant documentation, which in this case would be the relevant Wikipedia pages and the relevant, probably the sections from the Hubble Space Telescope Wikipedia page itself to get an answer from a language model. Okay. So the way that this process works on the back end, right, and this is kind of the system that we're going to be learning how to build in this course, is step one is it's taking the user's query and it's sending that to an embedding model. Okay, I'm not going to go too deep on specifics of each one of these because we obviously are going to have lessons upcoming that dive deeper into each one of these pieces. But the idea is the query gets sent to an embedding model, which is an AI model that basically takes the text or images. We're going to just stick with text for this example to keep things simple, a little simpler. But that text gets turned into this gigantic series of numbers. Okay. And what those numbers mean, what those sequence of numbers mean, is it basically is trying to encode the information that is stored in text. And it's going to change that into a number format that we can do a bunch of different operations with. Okay. That is what this query embedding is going to be. Okay. So you send your query to the embedding model. That embedding model spits out a query embedding, which is just a series of a bunch of numbers. What we typically do is we store this embedding in some sort of a vector database case. So we're going to be covering vector databases in detail and showing you how to set all that up. And you're typically doing some sort of a retrieval, similarity search to compare whatever the embedding you got back from the embedding model against all of the embeddings and the content that you have stored in your vector database. Okay. And so the output is you go through this whole process from query to relevant segments, and you're able to match that query to the most relevant kind of information that you have stored. Again, you combine that together, send that to, a Claude 3.5 Sana or a GPT-4o or a Gemini 1.5, whatever model is your preference, and then you get your answer, okay? So that's kind of the journey that we're going to be exploring here. We're going to be building each one of these steps from scratch, showing you how all these pieces of the puzzle fit together, explaining what those pieces are, why they matter, how to get the most out of them, and we should be able to get that all set up for you. So let's go ahead and end this lesson here and actually go set up some codes that we can actually dive into this thing. All right, so let's get some code set up. So what we're going to do is we're going to need you to navigate to the link below. So this is going to be the repository link. I will have that linked for you. This will be public by the time you see this. But what we're going to do here is, if you've been following along with all of our other courses on Takeoff, very standard process here. We're going to be using Git to actually clone the repository that we're going to be using to write all of our code for this course. Okay, so you're going to want to do one of two things. You can either download the zip file and just download that code directly, or the way I recommend doing it is directly with Git. This is just a good skill to use, and this is typically the way we go about our business here on Takeoff. So you're going to want to click on this big green button on this repository. You're going to want to copy this URL to your clipboard. Then we're going to want to go into a terminal here. So I'm on Mac. I am currently in my terminal here, and we're going to run git clone, paste that URL here, and you're going to see we have cloned the Takeoff RAG course onto my computer. So what I'm going to do now is I'm going to navigate by changing directories to the Takeoff RAG course here. You can see I now have that opened here in my terminal. And what you're going to want to do is open that in your IDE of choice. So I'm going to use Cursor here. This is a shortcut I have set up to open this. You may need to open it manually by just opening up the Cursor app and then opening a new folder here, open folder. Okay, you're just going to want to make sure that you get set up here. Again, I highly, highly recommend that you do, in fact, use Cursor. That is how we go about all of our projects here on Takeoff. If that changes, of course, we'll adjust. But for now, I think Cursor is by far the best AI coding tool out there. So once you have the repo here set up in Cursor, what we're going to need to do to make sure that you are all started here is we're going to open up a terminal here within Cursor. Okay, if you would prefer to use your custom terminal, that's great. I just like using the one right here in the IDE, super convenient. And we're going to run npm i. Okay, this is npm install. This is going to install the various packages here that we're going to be using in this project. Okay, so things like the OpenAI SDK, the Cohere SDK, things like that. Okay, so what you're going to also need to do here is for section 1, for the learning the basics section here, you're going to need 2 things. So if we go over to our sections folder, you'll see we have a folder that is 1, okay, section 1, learn the basics here. And this is going to be all of the code that we're going to be using here. Again, as I mentioned at the very start of this course, section 1 is mostly going to be something that you just watch me. We're going to go over conceptual things. And in section 2, we'll actually kind of build one of these RAG systems from scratch. If you want to kind of do this on your own and follow along and kind of write the code as I go, kind of explain what's going on, definitely a great exercise. More code that you can write, the better. It's going to drill the concepts better. It's going to give you a little bit of more, fundamental understanding of what's going on if you actually do it. But if you don't want to do that, we're going to kind of do everything in section 2. Okay, so more reps, the better, but don't worry about that for now. What you do need to worry about is you'll see in this .env.example file here in the Learn the Basics section, these are going to be the 2 keys that we need. Okay, so we're going to need an OpenAI API key here, and then we're going to need a database URL from Supabase. So you do not need these keys if you are just following along with me. So if you just want to watch these sections, understand conceptually what's going on in section 1, don't worry about this step. I am going to cover it here just for those of you who do actually want to run the code and maybe write these exercises out yourself. But basically what you need to do is you need to grab an OpenAI key here. Okay, so I'm going to do this after the fact here because I don't want to expose my key right now. And what you'll do is you'll just paste whatever that key value is in here. And then on the Supabase side of things, again, I mentioned you can get away with a free account here. Totally great. What you can do here is you can actually just create a new project here, fill out the project name here. You can use the micro size for on the free plan, and you'll just need to put in a database password here and save that. You can also generate one, which is typically what I do. Then you're going to want to click create new project. That is going to take you to a bit of a setup screen. You typically have to wait 1 or 2 minutes for the database to actually spin up. Okay. But once everything's done getting set up, what you're going to want to do is you're going to want to go to project settings here, and then you're going to want to go to database, and you need to do the following. You need to copy this connection string URL. Okay, so it's going to be this big string here right at the top. You can just click that copy button. You can paste that in here, and then you are going to want to put whatever that password was that either you entered yourself or you generated, and you are going to want to put that right here in this value. So if my password was this is my password, okay, that would be my value. And at this point, you would have both of those set up. So what I'm going to do here is you'll notice we're actually in the .env.example file, which I just noticed. You're actually going to want to create a new file in the same folder that is .env.local. Okay, so you should have next to your .env.example a .env.local file, which will be grayed out because we have ignored that forget so that you don't actually commit those. And what you actually want to do is make sure that you get rid of these values in example. You don't want to commit those, and you want to put those in your .env.local file. Okay, so things should look like this. You should have your OpenAI key right here, and you should have that database connection string here with whatever your password value is. So I'm going to go put mine in, and I will be right back. Okay, so I have gone ahead and put my environment variables in my .env.local, and what we're going to do to test that this is set up correctly is if you go to this one-setup file, so I've kind of numbered things so that they sort a little bit better as we kind of go throughout the section. But you'll notice we have a little bit of a very basic function here, which is that we're doing a very basic call to the OpenAI API with GPT-4o Mini. So we're using 4o Mini because it's a really cheap model. You can kind of get the most out of your API credits for testing purposes. And what you should be able to do is you should be able to copy the path here. So if I copy path, And by the way, I'm just right clicking. So we're just copying the path and we're going to run tsx space, and then we're going to paste that value in here. What we should see is, and you'll notice I'm actually getting a little bit of an error here. I suspect, oh, you know what, this actually is. So what we're going to need to do is we just need to navigate to this section. So you'll see I'm in RAG course in my terminal here. We're going to cd into sections. Okay, so that's just change directory. And then we're going to also go into this first section here. Okay, so you can see I'm now in that section. And if I hit my up arrow key, this is actually just going to populate. If I hit it 3 times here, we're going to get that command again. And I should be able to run it. And now we can see we're getting printed in our terminal, hello, how can I assist you today? Okay, so we got rid of the error message that was due to how our configuration is set up. So you're going to want to make sure you navigate to this folder here in your terminal. That's where we're going to be running the code for the section from. And if you go ahead and use tsx, which is TypeScript execute, with the file name, you're going to be able to get the response back. So you can see this line 19 here. We're console logging the response. We're logging the content of the message from the OpenAI API here. And that means your OpenAI key is working and you should hopefully be all set up here. So if you've got this working, that means you're probably all set to go on following along. Again, you don't need to follow along and write the code yourself here in section 1. You will want to do that for section 2. So feel free to kind of skip this if you just kind of want to get a conceptual understanding here. But I know a lot of you like the reps and you like getting the extra exercises in, which is something I do recommend if you have the time for it. So that being said, let's go ahead and move on to actually talking about embeddings. Let's talk about embeddings. So embeddings are a way that you can encode your data to make them much more easier to work with in all sorts of use cases. So one of the really great pages that I recommend reading is OpenAI has a vector embeddings page here on their developer documentation site here. So you can see there's a lot of information here that you can kind of read through. There's a lot of different code examples, a lot of different use cases it goes over. I do recommend reading this page. I think it gives you a really, really good idea of why embeddings matter and what some of kind of the common use cases that you'll typically see them used for. So I think the sentence here that really drives the point home and what we want to drive home in this course is OpenAI text embeddings, or embeddings in general, measures the relatedness of text strings. So small caveat here, we're going to be focused on text here. You can use embeddings on things like images and things like that, but just for simplicity's sake, we're going to focus on text here. So the idea here is we're trying to take a piece of text and we're trying to encode that data and get it into number form, okay? So let's talk about what embeddings are at their core, okay? You can see my slide here actually didn't update, so I gotta go make sure I might actually update that for you guys. But as I was saying, embeddings are a way. That's kind of hilarious. We're gonna keep that in. We have fun here at Takeoff. Okay, we gotta give people a little bit of reason to smile every once in a while, right? But in this course in particular, we're really going to be focused on the search aspect of embeddings. Okay, so what we're going to be doing is we're going to be taking a bunch of embedded text, right? So say you have 1,000 different documents, we're going to embed all those different documents, and then what we're going to be able to do is we're going to be able to get that embedding, again, that series of numbers that is now representing that text data that we have now encoded into sort of a big string of numbers, okay? And we're going to be using that for search purposes, okay? And so in this lesson, we want to talk about how do we actually generate those embeddings and what are some of the things that we're going to be able to do with those embeddings, okay? So let's jump back here into the slides here. So this is a really great example of an example embedding space, okay? So one of the things that's kind of tricky at first is you're trying to understand, okay, I get that embeddings take text and turn it into a bunch of numbers, but what I don't get with embeddings, right, and this is really common, so if you feel confused, you're not alone. It's very common for people to go, okay, how are these numbers compared against each other? So we're not going to get into kind of the mathematics of the thing. We're going to kind of just really simplify this. You don't need to understand all of the math behind how embeddings work and why there's so many numbers and what all those different floating point numbers mean. what you need to understand is that, say we embed something like garden, okay? So we're just taking literally the text, the word garden, we're sending that to an embedding model, okay, like OpenAI's text embedding 3 small model here, which is what we're going to use in just a sec here, okay. And what it's going to give us back is it's going to give us back a big string of numbers, okay. And what those numbers mean is you can basically plot in 3D space where that word sits. And what you do as you start embedding all of these other words is you start to get kind of all of these different points on a chart here. So for example, if we embed the word hose, we're going to get an embedding that's fairly close in terms of how the similarity search performs based on their numbers. Right, you can see garden and hose are very close together, right? Which makes sense. Garden and hose are fairly similar words. Obviously, they're not exactly, but if somebody said the word hose, you could say, okay, maybe their hose is in their garden, right? But for example, if somebody said the word garden and the word kitchen, right, those are going to be much less similar. So what you'll see here is the distance between those two, between garden and kitchen and garden and hose, are much further away, right? Take an example like color and paint, right? Color and paint, okay, paints are always a certain color, right? So those are going to be terms that are fairly close together. But if we use the term, color and microwave, right, those are going to be much further, right? And you can also see that you're kind of getting these groupings, right? Garden and hose and sprinkler kind of grouping down here, right? And then we have vanity, sink, bathroom, kitchen, toilet, right? These are all kind of grouped over here. So what you'll notice is if we were performing some sort of a similarity search and we said, hey, we need to ask a question about refrigerators or something. Well, what's going to happen is your similarity search is going to kind of go cluster over here and grab the documents in this area, right? So you can see sort of intuitively on a chart here how embeddings kind of make sense. The idea is, and this is just a really nice mental model, is embeddings are plotting all of these different words. In our case, it's going to be much more like paragraphs or entire documents, but they're going to try and plot them similarly together. And when we do our similarity search, if we search for concrete, right, we're going to be grabbing things in this area, right? And so this is kind of the basis of why embeddings are useful. You can kind of take the text, embed them into numbers, and then do all sort of these different operations, okay? So we're trying to take text, we're trying to encode that semantic information into a number form so that we can perform retrieval operations on it. Okay, so let's actually get more into the how to generate embeddings. Okay, so we actually need to see, okay, maybe we now are starting to conceptually understand this. And if you're still feeling a little lost, just hang in there as we start actually doing some of these things. I think things will click a little bit more. This typically clicks for people at different stages in different ways. So for some of you, this may click here, which is we want to open the to file here, the to generate embeddings, okay? And what we're going to do here is we're just kind of explain what's going on in this file here, okay? So at the very top here, we're just importing OpenAI and we're importing .env, okay? Again, we just need to import that environment variable. What we're doing here is we're initializing the OpenAI SDK. Okay, so this is going to allow us to use any of those API endpoints very easily with the OpenAI client here that we've saved as a variable. Okay, and what we're doing in this case is we're grabbing a response and we're trying to send a specific array of text here. Okay, so we're going to send a bunch of different documents. In this case, you can see the example we're using is hello world and goodbye world. So what we're doing is we're taking these two strings here, we're passing those into OpenAI's create embeddings endpoint via the OpenAI SDK here. We're using OpenAI's text embedding 3 small model. We're using 256 dimensions on these embeddings. I'll touch on that in kind of more depth in a few sections in the future. We'll talk about why embedding dimensions matter and how you can kind of optimize those based on your use case. We'll even talk about when you might want to use text embedding 3 small versus OpenAI's text embedding 3 large or another embedding model. Okay, but the point here is we're taking these two pieces of text, we're sending those to OpenAI's embedding model here. And the reason I've chosen these numbers right now is this is the cheapest way. Okay, so embeddings are super cheap, by the way. So if I pop over to OpenAI's pricing page in particular, you'll see text embedding 3 small, is about 6 times or approximately cheaper than text embedding 3 large. And then we're using smaller dimensions to make our operations a little bit faster, a little bit easier to store eventually when we get around to setting our vector database up. Okay, so that's the reasoning for why we're doing things with this particular model and this amount of dimensions right now. Again, we'll cover that more in depth as we get to more advanced RAG systems. But the point is we're inputting both of these strings and we're getting embeddings back for both of them, okay? So to take our plot example here, what we're doing in this step is we're trying to take those sets of words, right? Not individual words in our use case, right? And this is getting plotted on the diagram. So what I'm actually gonna do, okay, if we copy that file path and we go TSX, run that file, you'll see 2 things. So you'll see we're logging our response.data. Okay, so we're going to be logging the embeddings, which you can see we have all of these numbers here. That is an embedding. And you can see we're logging the length as well. So we're getting 2 embeddings back here because we were passing 2 strings in. Makes sense. If I were to do a third one here, which would be, my name is okay here. If we were to run this one more time, you'll see we'll get 3 here. And if we scroll up here, you're seeing all of this in yellow. For you, it might be a different color based on your editor theme. We'll make this bigger. But what you can see here is we're getting those embeddings. Okay, so this is a 256 long number array here. Okay, that 256 number comes from the dimensions. So what dimensions translate to is just the amount of numbers in the embedding that we're going to be using. Okay, so if you use the default numbers, I think the default numbers are like 1536 or something. We're using 256 to just keep things a little bit smaller, but we're getting all of these floating point numbers here, which are just big decimal numbers that all of these things combine to form where on our kind of figurative plot these sentences, these terms, these words should actually fit. Okay, so once we have the embedding for this, the way we're going to go about this in the upcoming lessons is we're going to figure out, okay, how do we store this piece of text with its entire embedding in a vector database, okay? And then how, once we have that information stored in the vector DB, how do we actually perform some sort of a similarity search, okay? So all of those pieces are going to be what we're going to be covering in the upcoming videos here. So you can see, we're going to go through uploading the documents. We're going to do retrieval. Okay, so we're going to learn kind of how all of these embeddings actually get used, but at a very high level, this is what embeddings are. It's a way to take text, encode that data, and we want to be able to use the kind of the outputted number to measure the relatedness of those strings. So I recommend going through OpenAI's page here. Their docs are really good on this stuff. You can also check out the API reference here if you want to see kind of a little bit more in depth on what some of these parameters are. We'll be covering these in detail as we kind of build out these more and more advanced RAG systems here. You can even click on the embedding models. Okay, we're going to be using the 3 series, so we're going to be using text embedding 3 small in this video, but they do have a more powerful model that is the large version, which is just, again, it's just a lot more expensive. And again, the pricing here is really cheap. So if we're using GPT-4o Mini with text embedding 3 small, things are going to be really cheap and easy to work with here. Okay. So hopefully you understand a little bit more about what an embedding actually is and how we're encoding the information here and how that kind of plays out into, again, our figurative chart here where we're just trying to construct some sort of an embedding space. We're trying to take all of these words, all of these sentences, all of the text information that we're working with, kind of get the number that we can work with, and then actually perform operations on it and store that data so that we can build advanced retrieval systems. So let's actually get into the usefulness instead of just the what is an embedding? How do we actually use this thing? So now that you have a little bit of an understanding of what an embedding is, how to generate embeddings with an embedding model like OpenAI's text embedding 3 small or large models, let's actually talk about how you can store those embeddings with their related text in vector databases, okay? So vector databases are going to allow you to store your embedded data. Let's talk a little bit about what vector databases are and why we need them. So at their core, vector databases or vector DBs are basically specialized databases that are specifically designed to store vector data, okay? So when we say high dimensional vector data here, again, what we're referring to is we're referring to the dimensions of our particular embedding. In this case, in our example, we're using 256 dimensions, which via the OpenAI API is the smallest amount of dimensions you can use. Again, those dimensions correspond to the number of numbers you're going to get in your actual embedding itself, right? So if we were to make this 1,000, we'd get 1,000 numbers. If it was 1,500, we'd get 1,500 numbers, and so on. And vector databases are very efficient databases that you want to use for embeddings, okay? So you don't want to use a traditional database because the problem with that is the storage gets super expensive. Your queries are very slow. It's highly inefficient. It quickly becomes an absolute nightmare if you don't even need to scale to millions of users. You start scaling to even hundreds with the traditional database, and you'll start to run into all sorts of problems. The column types in those databases are simply not built from a technical perspective to handle those high dimensional vectors. So one thing I want to note right at the top here is embedding and vector. You can kind of use those interchangeably. There's some nuance there, but you can almost replace vector database with embedding database. Those two essentially mean the same things for the sake of what we're doing here. But what we want to do is we want to talk about the different kinds of vector databases that exist out there, why we're going to be working with a very basic Postgres database with a extension called PG Vector is our database. And I just want to give you a little bit of an overview on kind of what the landscape of vector databases looks like and what the market kind of looks like. So again, we're going to be using Supabase, which is simply just a Postgres provider. The reason we use Supabase on Takeoff is that's what I use for all my personal projects. For many people, for most people, it's going to be the easiest way to get started with a Postgres database, which is one of, if not the most popular database in the world. Okay. And the reason that I like to use Postgres for my vector database is because it takes the existing technology stack that I'm already familiar with, that already works with my entire tech stack. It's reliable. It has widespread support for everything. And we're going to simply slap this extension called PG Vector on top of Postgres, and it's going to give us an additional column type that is going to take everything that we love about a SQL database, about relational databases, and it's going to allow us to now be able to take that technology and add the ability to have a vector column. Okay, so we're going to be able to actually store a specific vector column type that is going to allow us to store all of those embeddings that we're going to generate in an efficient way. It's going to allow us to spin up an index so that the queries we make to those tables with the vector column type are going to be efficient. It's going to be scalable. So the reason I kind of like to work with this particular technology stack, and you're seeing a lot of people, even companies at scale, in a lot of different ways work with this because it just works out of the box. The open source community around Postgres and around PG Vector is very strong, and it just kind of works. That being said, different problems require different tools, and that's why we have all of these other different databases, things like Pinecone, things like Weaviate, Qt, Chroma. Okay, these are more traditional vector databases. Okay, the PG vector approach essentially takes the existing technology that we love and are familiar with, and it makes it accessible and it makes it work with the kind of typical problem sets that you're going to be running into with vector databases. Pinecone, Weaviate, all these other ones, these are going to be more geared to very standalone vector databases, right? These are going to be things that you're probably going to not use traditional databases for. You're just going to use your very specific embedding workloads on, and using these different things is going to depend on what you're trying to work on, what problem you're trying to solve, what scale are you trying to solve that problem on, right? Do you have, is this an internal tool, right? If this is just, your own company, this is going to be great. Postgres is going to be great. If you're doing something like building a memory agent for millions of users, you may want technology that's a little bit more dedicated to the actual vector use cases. So those conversations, if you're in the position where you need to have those conversations, right, if you're actually operating on that scale, you're probably going to want to consult somebody that has expertise at each one of these junctions, right? whether you're, CTO looking to pick a technology stack, you're an engineering team having these discussions, you're going to need to really evaluate that on a case-by-case basis. But for the overwhelming majority of people who are watching this video and are kind of on Takeoff, you're going to be right with the tech stack that we're going to be working with here. The great thing about Postgres is if you don't want to use Supabase, no problem. There's obviously many Postgres providers out in the world that you can use. Again, we're going to be using Supabase here with our Postgres setup just because it's what we use on Takeoff. It's really easy to get set up. It's very familiar. The tooling's great. And anything that you want to use, outside of the Supabase ecosystem, you can, right? Because Supabase is open source. It's just Postgres. So if you want to go use Postgres somewhere else, totally good. So these are kind of some of the more popular Postgres databases, the more popular vector databases rather. And we're going to be using Postgres with pgvector so that everything that we do on Takeoff kind of matches up with what you will see in this lesson. Okay, so let's actually go ahead and get a vector DB set up. So we're back here in our repository, and what we're going to do is we're going to go to this third file here, this upload docs. So what we're going to be doing is we're actually going to be uploading these 10 different documents to a vector database, and I'm just going to show you what some of the moving parts are that we're going to be working with here. In section 2, we're going to set this up from scratch. So don't worry if you're kind of following along, you don't really know what's going on. The idea here is we just want to drill concepts. We want to drill. Here are kind of the moving parts of how to set up a vector DB within a Postgres environment. And, what are some of the little things you need to pay attention for? So again, I do recommend if you have the time, go ahead and write this code from scratch and get a little extra practice in. Maybe run the files, but it's not necessarily needed if you just kind of want to go over concepts. So we're going to be using a tool called Drizzle. Again, we use this all across all of our database needs on Takeoff. It's basically what's called an ORM that just gives us a really easy way to work with kind of migrations and building out our different table schemas and things like that. And so what we're going to be doing is we're going to be going to this DB folder here. And what I have here in this folder is I have another folder called schema, and we have a single file in it called documents-schema.tsk. So this is a TypeScript file that is defining the table that we want to upload or that we want to create in our Supabase database. Okay, so if we go over to Supabase here, this is the project that I spun up. It's just called Playground here. If we go to our table editor here on the side, you'll see that we don't have tables. Okay, so what we need to do is we need to actually generate a documents. We need to generate the SQL migration file that we can run so that we can actually use this table here with the embedding vector column here, which is enabled with pgvector, as I just kind of mentioned in the slide there. And what we're going to be doing is we're going to creating that table, and then we're going to be creating an index here that's going to allow us to perform things like similarity search on this table. So this is in Drizzle. All you need to do in order to actually build one of these tables. So the way you're going to set this up is you're going to typically call your column embedding. Okay, so you can see I'm just calling this embedding, and it's wrapped with this vector helper here. And all we have to do is we just have to define how many dimensions that we're going to be using. So again, this is just corresponding directly to the embedding dimensions that we specified from our embedding file here. Okay, so we're going to be consistently working with 256 dimensions. Once you pick your dimensions, it's going to have to be consistent. So you can't have 1,000 dimensions and 500 dimensions and 256. You have to be standard here. So just make sure that you get that number set, and that it is the same thing between what you're generating on your embeddings and what you're storing in your actual table. Okay, so this is the only column type that we really need to worry about to use pgvector, which is awesome. This is one of the great things about pgvector. It's really easy to set up. And we're also going to need to create an index here so that we can perform things like similarity search. Okay, so we're going to be using cosine similarity. So you can see this is kind of the syntax in Drizzle that we need to use. If you're not familiar with Drizzle, no problem. We're going to actually generate the SQL, and I'll show you what that is. So if we go to our package.json file, you'll see we have these two scripts that correspond to the operations we're going to be needing for section 1 here. So if we use db generate basics and db migrate basics, that is going to take care of turning this drizzle file here into actual SQL code. So what we can do is we can do npm run db generate basics. And what this is going to do, again, we're just sitting here in the one-learn the basics folder here. You can see we now have a migrations folder here. When you see this, I might actually upload this to Git. So you may actually not need to generate that for this section. But what you can see here is we now have almost all of the SQL code that we need to actually get this set up. Okay, so this is what that code looks like in Drizzle, but once we actually translate it from Drizzle syntax to SQL syntax, this is what you work with. So the only thing that you need to add is you have to actually enable the vector extension. So we're going to do create extension if not exists vector, and this is going to be the code that actually enables the PG vector extension. So most Postgres providers at this point have compatibility with PG vector. I would be really surprised if you're using something that doesn't at this point. If they don't, that might be a bad sign. Probably not a great vendor, to be honest with you. But this is all the SQL code that you need, okay? So the great thing here is whether you're using our tech stack, we're using Drizzle because it's just really easy to work with. But if you don't want to use it, right, you just copy all the SQL code and boom, you've got your table, right, on whatever Postgres provider you want. And this is all you need, okay? So again, it's kind of 3 parts. You have to enable the vector extension, okay? Makes sense. You have a Postgres database, we want to add that extension. Great. The other thing we're going to need to do is in our table that we create, we're going to need to create that vector column, okay? That's the entire point of using PG vector, is it enables the use of PG vector as a column type. Okay, so we have this vector type, we're calling it embedding, and we're specifying that we're using 256 dimensions for our embeddings. And last but not least is we actually need to create this index here so that we can actually perform operations on this table in an efficient manner and start getting to do things like actual retrieval and cosine similarity and some of these things that we're going to be going over in the next lesson. So once you have that set up, what you can do is we can do npm run db migrate basics. And what this is going to do, oh, you know what? I actually have to go. I'm going to go tweak this really quick, guys. It looks like in the drizzle config file I may have made a slight syntactical error. I'll be right back. So I'm just going to run, let's run npm run db migrate basics. Okay, and this is going to apply our migrations. And so now if I go back over to the Supabase table editor area, you'll see we now have a table. Okay, that table is called documents. We have all of our column types, including this column called embedding, which is of type vector. Again, this is what PG vector enables. This is kind of the entire point of using Postgres with the PG vector setup here, which is awesome. We now have Postgres with vector database capabilities. Love it. Okay, and now what we can do is we can actually upload the information, okay, so the embeddings with the text that we want to our table. So you'll see here in the 3 file here with the upload docs, what we're going to be doing here is we're going to take all of these kind of mock docs, which are just like a bunch of fake animal facts. I don't know. This is what the AI generated for me. But what we're going to be doing is we're going to be running all of these mock docs through this upload documents function here. Okay, so we're going to be generating and embedding, again, with the same dimensions, the same model as we were in the previous lesson here. We're going to be getting those embeddings. We're going to insert those embeddings with the content, with the name of the doc, which is just the fun fact number. With the embedding, we're going to upload all of that to our database. And after we run this file, so if we copy this path and do tsx space, file name, enter, if we run this, what we're going to do is we're going to get those 10 embeddings generated, and then we're going to insert that data into our database. So if we go over to our file here, what you'll notice here is that this operation is complete, which is really cool. And we now have 10 fun facts, 10 animal facts embedded in our vector database. So you can see if I kind of expand this a little, you're going to see I can't really click on this because it's 256 numbers long, right? We're storing a ton of data in here. But the point is that we embedded the actual content of the fact here. Okay, so you'll see if we go over to our call to the OpenAI API, okay, the thing that we're embedding, the actual input, was we're embedding the document's content. Okay, so that's the actual fact itself, not the name. It's just the fact itself. So what we're doing, again, to do a little callback back to the embedding section, we're taking this content, we're passing that into the OpenAI embedding model. We're getting this embedding back for each one of these facts. Okay, so each one of these pairs matches up. And what we're doing is we've set up a vector database here in our Postgres table, in just a standard SQL table. We have access to this awesome vector column type because we've enabled the PG vector extension. Okay, we've enabled that extension. We've defined the 256 dimensions for this vector. Okay, so our embedding matches up with what our vector database expects the data be stored as. And then what we have now is we have this index that's built that is going to allow us in the next lesson to actually do retrieval on that. Okay, so that is the very basis of how to set up a vector database here. Okay, super easy, super concise, not a ton of code. Again, this is all the SQL code it's taking to get a table running with embedding support. Pretty cool. Okay, so in the next video, we're actually going to get into some of the similarity search aspects and how we can actually take advantage of this setup now that we've gone through all of kind of all of the setup steps. How do we actually apply what we've learned to actually do useful things? One more quick add to this section. I just want to mention Supabase has this AI and vectors section in their documentation that is one of the better resources, in my opinion, on vector databases and vectors and embeddings. They have a ton of really good resources here. So I'm just going to throw this at the end of the video here just to show you what, if you want a little bit more to go read. They have a ton of code examples. They have a lot of, really in-depth discussion on different types of indexes you can use. I just use the most common one. To keep things simple for now, we might talk about that later. Things like going to production, if you need to actually engineer things for scale, if you're somebody who's, operating on the order of, millions, hundreds of millions, billions, potentially even vectors, you may want to be more familiar with some of these other things. And then the only other thing I really want to talk about is, we went over kind of some of the other vector databases, but I do want to just highlight that conceptually, all of the steps that we just kind of went over are going to stand, true no matter what database you're working with. Okay, so we obviously are using Postgres with PG Vector, which I think is awesome. I think it's the easiest way to get started, and I think it's really flexible too because it's very easy to transition off of that if you need something that's a little bit more vector DB specific. Maybe you have a different workload. You have some different set of trade-offs that, you and your team may need to address. But like if we just go through the Pinecone database quick start. So Pinecone is one of the more popular, called quote unquote pure vector databases. You can see that things are, pretty simple here. You generate your vectors. Okay. You create an index, you insert those vectors into the database, and then you perform some sort of search, some sort of retrieval step on that index. Okay, so it's the same kind of step. The only thing that's going to change is the specific code, right? The SQL code is going to be different than whatever Pinecone expects. Obviously, it's not a SQL database; it's kind of its own thing. But conceptually, right, all the steps are the same. You take text, you generate embeddings of the text, you upload the text with its embedding to some sort of a vector store. Okay, in our case, it was with Postgres with PG Vector. In this particular case here, it would be Pinecone with their own kind of version of doing things, right? And then it's performing some sort of search, okay? So conceptually, the entire step-by-step process is going to be the same. It's just some of the technical implementation in between is going to change, okay? So once you understand how the system works as a whole, it's very easy to kind of go between each one of these providers and just figure out what their way of doing it is, but all of the core steps are going to be the same. So I just wanted to add that at the end here, just in case there was any confusion on kind of some of these other options. So a great exercise, for example, would be doing a vector database, how we just did it, and then pick Pinecone, right? Go try and do it with Pinecone, see what you like more, see how the costs play out, right? I will say, these are typically going to be much, much more expensive, maybe a bit more efficient, especially at scale, but you're going to be paying a premium for it. And again, all of those things are just going to be discussions that you need to have with your engineering team. And if you're operating at scale, which is obviously a great problem to have, congrats on that. That's awesome. then you can kind of go into those discussions, maybe consult some people that have worked with the different stacks and see what works for you. But by and large, again, 95% plus percent of you are going to be awesome with this solution. So I just wanted to add that at the end here. We've at this point gone through all of the trouble of getting our base infrastructure set up with our vector database. We've learned how to actually embed our text, how to store that in a vector database, all that kind of stuff. So let's actually get into doing something useful with all of that, which is similarity search. Okay, so we're going to be going over how to retrieve embedded data from your vector store. Okay, so what is similarity search? Basically, when we're talking about search in the context of vector databases, what we're essentially trying to do is we're trying to compare the embeddings, right? To compare those text embeddings to find the most semantically similar items, okay? So when we were talking about this example here with the guard and the hose and you know, how do we compare, battery and drill versus battery and color, right? This is where that computation happens for similarity search. Okay, so what we need to do, obviously, in this example, we can kind of visually see how close things are to one another. But when we're actually working with the embedding in number form, what we need some sort of an operation to perform that computation and to perform that similarity search so that we can kind of get an actual computed number for how similar each one of these embeddings is. Okay, so that's where similarity search kicks in here. And what we're going to be doing here is we're going to be showing you how to actually use that. So what we're going to be doing here is we're going to be taking the embedding from our query. Okay, so what we're going to be doing is we're going to be taking the query, we're going to convert that to a vector embedding. And what we're going to do here is we're going to calculate the cosine similarity of the query compared to the embeddings that are stored in our table for each one of our relevant documents. Okay, so what we're going to be doing is you're going to be first grabbing those embeddings, which in this case we're just embedding the query. We're then taking the similarity calculation here. And one of the really great things about Drizzle here is we get cosine distance right out of the bag. So basically what the cosine similarity function is doing at a mathy level is you're effectively trying to calculate the similarity between vectors by calculating the cosine of the angle between them, which again, we want to stay away from the math stuff as much as possible and just get to the practicality of things. But effectively what we're doing is we're just trying to measure the similarity of our query to the embeddings that are stored in our table. Okay, so we go back to our SQL table here. What we're going to do is if I say, facts about rhinos, what we'll do is we'll take, this embedding and we'll compare that against the embedding that we get for our tell me about rhinos query. And this one's not going to be that similar, right? Because we're kind of talking about flamingos, but it's going to be a little bit similar, right? Because we're talking about animals, right? So there's going to be some similarity there. But if we go down to fact 6 here, you'll see, we directly have a fact about a rhinoceros, right? So that embedding is going to be really close. So what's going to happen is if we go back over to our code, we're going to kind of sort these out and return all these documents. And what's going to happen is we'll kind of get a little bit of a feel if we actually log these out for what is the most similar document. And what happens in a RAG system, right, is you kind of sort based on those similarity scores. Maybe you grab the 5 most similar, what have you. You can see here we're ordering by descending similarity here. So if we do something like, again, let's actually just use our rhino example. Tell me about rhinos. Okay, and let's do a limit of 3 here. What we can actually do is if we copy the file path here, okay, and what we're going to do, we'll go TSX, we'll run this right here, and you can see what's happening is we're actually getting the documents back. Okay, so let me, before I actually show you these results, let's just go over this one more time just to make this crystal clear what's happening here. So what we're doing is we're running this retrieve document function with this query. Okay, tell me about rhinos. So what's happening is we're taking that query, we're generating the embedding for it, and what we're doing is we're calculating the cosine distance between this embedding, okay, so the embedding of our query, and all of the embeddings here in our table. Okay, so in this case, we're calculating the similarity between these 10 things. So what's happening here is we're running that query, and we're trying to find the 3 most documents, okay, because we're using a limit of 3. We're trying to find the 3 most relevant documents based on similarity score. So the higher the score, the closer to 1 our similarity score is, the more relevant the fact, okay, in the context of the use case that we're kind of going through here, the more similar our fact is going to be to Rhino. So I would suspect that our Rhino fact should hopefully rank kind of at the top here. So let's look at our results here. Let's go up to the very top one here. And you can actually see, so this is where it starts, everything in blue here. I'll just highlight it so it's easier for you to see. You can see, sure enough, the fun fact 6, a rhinoceros's horn is made of hair. That is the most relevant document from our table, okay? For some reason, it thought slugs have 4 noses was second, and third was elephants. So you can see sometimes you get unexpected results. I kind of would have thought intuitively that maybe elephant fact was maybe more similar. I would have flipped those two. But sometimes you never know with embeddings. But you can see, sure enough, the most similar fact that we got back was the rhinoceros's horn is made of hair. So one thing that you could do in the context of a RAG system, right, is you could get that fact, you could inject that into a prompt, combine the query here with the fact that you get here, which in this case was I scrolled up too much here, was a rhinoceros's horn is made of hair. And then if we go back to our slides, we're going to go back way back here. We go back in the context of this RAG overview that we did a few lessons ago, right? What's happening is we finally went through all of these steps, right? We gave it the tell me about rhinos query here. Okay, we got the embedding for that. We compared that against our documents here in our database here. We got, the most relevant ones, and we combined the query to the segments. And then we didn't actually make the call to the AI model. We'll go about that in section 2. But we kind of have the entire retrieval process done, right? We went through all of the steps for that. And at this point, we can make the call to, a GPT-4 or what have you, so that we could actually get an answer back that was grounded in, our little list of facts here. So this is obviously a really silly little example here, but it drives home the core concepts that power much, much more powerful systems, right? So once you have kind of this simple example down, you can quickly see how, what happens if you switch this table from dumb, silly little fun facts about a few different animals to what if you have 1,000 documents here that are all, related to, earnings reports, right? What if you want to do some sort of earning report chatbot, and each one of these is like a PDF of an earnings report, and you're trying to pull the most relevant, so let's say, hey, what was Google's earnings in Q3 of 2024 or something like that? Okay, boom. Now you have all of the fundamentals that you need to go build that project, right? So obviously we want to get to building some more useful things. We want to build these systems from scratch. So this is kind of the end of section 1 here. Again, these are all the basics. It's embeddings, it's vector databases, it's similarity search, it's learning how all of the moving pieces of the puzzle fit together so that you can actually build these retrieval systems. So in section 2, we're going to do this from scratch. Okay, we're going to learn how to build one of these end-to-end RAG systems completely from scratch, and we're going to be going over a use case that's similar to this, but we're going to kind of go over some more advanced retrieval techniques that you can use to really optimize the results that you get at the very end of the step here. In this section, we're going to be creating a complete end-to-end RAG system from scratch. Okay, so we're going to be going over all of the previous steps that we did in section 1, except this time you're actually going to write the code from scratch with me so that you can kind of learn how to go from an idea to actually building one of these RAG systems in practice. Obviously, all of you are here because you probably have some sort of an idea that you want to execute on. And by the time we get done with this section, you should feel very comfortable executing on your ideas and building a pretty advanced retrieval system. We're going to go over a bunch of different stuff, but first we want to do a quick little intro lesson here just to make sure that everybody is set up appropriately. So step 1, we just want to make sure that you have the code that is for this section. So if we go back over to cursor where you may or may not have your code. So if you go back to the previous section, we have the code setup lesson. Make sure that you get to this point where you have the code report repository for the RAG course all downloaded. And what we want to do is, because some of you probably, most of you in fact probably already have this set up, we want to make sure that you pull the latest code because we are going to continue to update this over and over to reflect the latest changes. So if you go over to your terminal, you'll see I'm right here just at the very top level of this project repository. We're just going to do a little git pull origin main, hit enter. what you should do is that should fetch the latest code for you. If for some reason that doesn't fetch, you can always go straight to the GitHub repository, which we'll have the link below for. You can download that zip file and get the code for section 2. To make sure that you have that, you're going to want to go over to the left here in your file navigator here, click on sections, and make sure that you have the reference code folder here, which is all the reference code that we're going to be writing from scratch. And then you have this your code folder here. Okay, so you're going to want to make sure that you have this create a RAG system folder here with all this good stuff, because this is where we're going to be working for. I believe this section is going to be about somewhere between 10 and 12 lessons. So we're going to be doing quite a lot. So it's very important that you make sure that you have that code so that you can follow along. Okay, so what we want to do next here is we want to talk a little bit about what we're going to be building here. So in this section, we're going to kind of bounce off of the or piggyback off of the theme from the last section, which is we're going to continue with kind of the silly animal facts example. I know it's very simple. And so why are we going to be using such a simple example? Why not something a little bit more interesting? So the goal here is we want to go over all of the setup steps and the core concepts from scratch. Okay, so this is things like learning how to write the code for generating embeddings, getting your vector DB set up, doing things like document re-ranking. And I've just found that if you try and combine all of the stuff that we're going to go over in this section with a really advanced concept, people can start to get a little bit lost. It helps to really scope down the data the first time you do this. So we're just going to continue along with a really simple little data set here. It also helps because then you don't have to go wrangle a data set. So what we've done is you'll see we have this mock data.ts file, and we have this giant array here of about 100 different animal facts. So I think we have like 20 different animals with 5 facts each. Okay, you'll see we have this elephant wiki thing here, which we'll work with later as well. The point is once you learn how all of these different moving parts work with a really simple example, it's really easy to just kind of increase the complexity of data that you're working with. So the focus is much less on the specific data set and much more on the actual concepts. So we'll obviously scale complexity in the next section when we actually get to kind of building a real world project that has a much more advanced data set, but that's kind of why we're going to be sticking with that simple example. Okay, so what are we going to be learning in the section? Okay, so as I mentioned, this is going to have this is going to be a section that's packed with a bunch of lessons. Okay, so we're going to learn how to set a vector DB from scratch, basic retrieval techniques. We're going to do some RAG prompting, things like query optimization, document re-ranking, metadata filtering, which is useful. And then also we'll learn very briefly, we'll touch on text splitting. We're going to get more into to document splitting and things like that in section 3. But this is all kind of some of the stuff that we're going to hit. All of these are very core concepts that you're going to want to learn how they work, how to build them from scratch and write the code and get all these pieces fit together so that you can actually build RAG systems. These are very common. We kind of picked all the main concepts that we think that you need to know to build the best retrieval systems in the world. Okay, so that's what we're going to be learning. A couple other setup notes really quick. You may already have an OpenAI key from the previous section, but if you don't, you're going to want to make sure that you go over to OpenAI's developer platform and grab an OpenAI key from them because you're going to need that. Okay, so I actually have in my code here what we need to do here. And actually this is unlike last section. I want you to follow along with every single thing that I do. Okay, so the goal is we actually want to write the code for this and do this. So you'll see in the your code file here, and just as a quick note, the reference folder is meant to have all of the reference code, right? So if I click into this optimized query file here, this has the function that we're going to be writing. We're going to be doing this from scratch, but we have each one of these fully written out so that if you want the full code that you can reference, that you can look at, we even have comments to kind of explain some of the things around that. That's what this is. Okay, so you can run anything you want. That's the complete code that we're going to be doing in this section. And then the your code folder is where I want you to follow along with me. Okay, so that's kind of how we're going to be going about this section. So the first thing that we need to do here is create a new file called .env.local. .env.local. There we go. And what you want to do is go into .env.example, copy all these values, paste this into .env.local. You should probably see that that's grayed out. Okay, so we're not going to be committing our API keys to Git or anything like that. And what you want to do is you want to put your OpenAI key there. Okay, you want to put your database URL here, your Cohere API key here. Okay, we're going to get to these other two in just a second here. So make sure you go grab that OpenAI key here and paste that value here so that that's ready to roll. And what we're going to be doing as well is we'll be using Supabase, just like we were talking about kind of on the infrastructure side of things in the previous section. Okay, so we're going to be using that again. So make sure if you weren't following along with the code in that section that you actually take the time to get a Supabase account set up. Again, this is free. They have a free tier that you can use, and that's going to be perfectly sufficient for all the work that we're going to be doing in this course. So that's great. We'll get to this actual key in the section coming up here when we actually get to setting up the vector database. So you can actually skip this database URL for now. And then the third thing that you're going to need to do, and this is a little bit optional, I do recommend it, is you're going to want to sign up for the Cohere API. So if you sign up for the Cohere API, it's going to take you to a dashboard. And if you click into API keys there, you're going to be able to create an API key. I believe they let you have some free usage here. So I believe you actually won't need to spend any money for Cohere. And if you do, it's going to be, it's usage based, very similar to how the OpenAI API works. So you aren't going to be spending a ton of money. All the stuff we're going to be doing here is very cheap. So once you have that, you're going to want to paste that, your API key here, whatever that is. Okay, so I'll obviously go do mine off screen to keep things secure. But those are going to be the three values that we need. We'll get to the database URL and the VectorDB lesson, so don't worry about that just quite yet. Just want to make sure that you have that. So once you have that, you're going to have your OpenAI account, your Supabase account, and optionally your Cohere API. We're going to be using this for the document re-ranking sections, and it also gives you some additional flexibility if you want to try out another embedding model if you don't want to use OpenAI. So it just gives you a little bit more flexibility. But once you have that, come back here because we're going to be going over how to set up a VectorDB from scratch. Let's actually get our vector database all set up. So you should have kind of all the fundamental understanding of why we need to do this setup step. So again, setting up a vector database allows us to work with vector embeddings to store all of those numbers that we were generating from the OpenAI API when we were grabbing all those embeddings and allow us to actually perform operations on them. Okay, so let's actually get this thing set up. So we're going to be using kind of three pieces of technology here in our vector database stack. Okay, so we're going to continue to use Postgres with pgvector. Again, we want to just use classic Postgres here for all of the things that we love about a SQL database. And we're going to use that pgvector extension so that we have support for vector embeddings with that, okay, because that does not come out of the box with Postgres right now. We're going to be using Supabase to really easily get a Postgres DB set up. Okay, so that's going to be super easy to use. Again, that is going to be available on a free tier for all of you guys too, which is really convenient. And last but not least, we're going to be using an ORM called Drizzle in our code. It's just a really easy way, especially when you are working with something like TypeScript, to just manage data schemas and migration files very easily and keep everything type safe with your code. Okay, and Drizzle also comes out of the box with some really nice utility functions for things like calculating cosine similarity. Again, we touched a little bit on this in the previous section, but this is going to form the core three parts of our tech stack. Okay, so let's actually go ahead and start writing the code here. So we're going to need to do a bunch of different stuff. So the first thing that you're going to want to make sure that you do here is we're actually going to navigate in our terminal case. So whether you're actually using whatever the native terminal is on your operating system or the terminal here in Cursor, which is what I'm going to be using. What we need to do here is we actually need to navigate inside of sections, inside of create a rag system, and inside of your code. Okay, so let's go ahead and do CD for change directory here. And then we're going to go sections. We're going to go create a rag system, and then we're going to go all the way into your code. Optionally, if you want, you can also follow along. I'm going to show you a little bit how each one of these is going to work beforehand. I may use some of the reference code. So what I'm going to do is I'm just going to hit this plus sign. Again, you don't need to do this necessarily, but I'm just going to do this since it's helpful for teaching here. I'm just going to jump into the reference code terminal as well. Awesome. So I'm going to click back here into the your code terminal. We're going to go ahead and get started here. So before we get to writing code, let's actually get our Supabase project set up so that we can actually use that database URL that I was talking about in the previous lesson here. So what we're going to be doing, we're going to go over Supabase here. I'm just going to click on my dashboard here, and you're going to want to create a new project. Let's see, you're going to want to choose an organization for that. So I'm just going to choose Takeoff projects here, and I'm just going to call this animal facts, because that's kind of the theme of what we're going to be doing here. And I am going to generate a password because Supabase has a really nice algorithm for generating those securely. I'm going to copy that value. And what I'm going to do is I'm going to jump back into this your code here. And I'm just going to save this in .env.example for a second here. Just bear with me as we kind of work through this. Again, you should be able to create a project on the micro tier, on the free tier. I believe Supabase lets you create up to 2 projects, I believe it is, for free. So if you already have 2, you may have to delete one or something like that. But you're going to want to go ahead and create a new project. This is going to take a minute or 2 to set up. So I'm going to cut back once this project is all set up. Now that our project is set up, we're going to go over to project settings down here, the bottom here. What you want to go grab is you want to go to database here in the sidebar on the left, database. You're going to grab your connection string. Okay, so this is going to be the database URL that we need to connect to. So you're going to want to copy that value. And what we actually want to do is we're going to go paste this in here, and we're going to grab our database password here. And what you actually need to do is see how it says your password in between these brackets here. You're going to want to go ahead and paste your password in there. And then what you want to do is you want to cut that, and you're going to go over to .env.local. And in your database URL, you're going to want to paste that full value. So I'm just doing the example just so I don't expose my other keys right now. I actually have to go change my password now that I showed you guys this. But you're going to just want to make sure that instead of in your .env.example file, okay, so in your actual .env.local file, that you have your OpenAI key, your database URL with that password replaced in your Cohere API. Okay, so once you have all those 3 things, you're going to be set there. So I'm actually just going to really quickly go update, reset my password, get that pasted, and I'll be right back. Now that I have successfully entered all of my keys into the .env.local file, we can actually get working and get our Drizzle code written so that we can actually write the TypeScript code that we need to get our migration, our SQL migration generated and actually migrated so that it is showing in our Supabase project here. So the first thing that you need to do, again, it's really important that you make sure you are in the correct directory. Again, you want to navigate down to the your-code folder here. Otherwise, you're going to run into some issues and potentially run into some errors that are going to be a bit annoying to debug. But what you want to do first is I've actually taken the time to just get us set up with all of the scripts and the packages that we need. You will just need to install those with npm i. Okay, that's npm install. That's going to install all of the different SDKs that we're going to be using in this section. And then once you have that done, the first thing that we're actually going to do is in the your code folder here, we're going to create a new folder and we're going to call this DB. Okay, and then inside of the DB folder, we're going to create one more folder called schema. This is where our schemas are going to be living. Inside of schema, we're going to just create, we'll just call it facts-schema. I believe that's what we called it in the reference code. So we'll try and keep those consistent so it's easy to follow along for you guys. And then inside of DB, okay, so not inside of the schema, you're just going to want to create another file called index.ts. Okay, so the structure of this should be your database folder. That folder should have a single file, index.ts, a single folder, the schema folder, and inside that schema folder, a facts-schema.ts file. We're going to need one more file inside of your code, okay, not inside of the database folder, and we're going to call this drizzle.config.ts. Okay, so this is where we're going to set up the configuration that we need to get Drizzle set up. Again, we're going to be using Drizzle because we get a really nice set of utilities out of the box with things like type safety because we're working with TypeScript, really easy way to manage migrations, and we just use it on Takeoff all over the place. So we're just going to stay consistent here. So let's actually get this set up. So the first thing that we're going to need to do, and again, anytime that you want to reference the complete code for any of these files, just click into that click into that reference code folder here. And for example, this is the reference code for the drizzle config file, right? Literally, you could just copy and paste that right in here, and you'll be all set and ready to go. We're going to do that from scratch just so that I can kind of talk about each line so that you actually have an understanding of what's going on. Again, we tried to do the no code stuff in the previous section. In this section, the goal is to write some code. Okay, so to set up drizzle here, first we're going to import our config. You'll see I'm getting some gray populated text. That's a feature of Cursor Tab. If you're not familiar with Cursor Tab, I recommend checking out the Cursor course that we have on Takeoff, because we are going to be using some of Cursor's features in here, which I highly recommend. So I'm just going to hit Tab, and that's actually going to populate. We're also going to want to import define config here from Drizzle Kit. We're going to go one line at a time. I won't overdo it on you guys. And then right at the top here, we're going to be setting up our configuration here for our environment variables. So we just have to specify the single parameter called path. And that's just going to define that we are pulling our environment variables from that .env.local file that we've already set up previously. Okay, so now that's all ready to roll. What we have to do here is we actually just have to set up our drizzle config. This is just going to set up a few different things. Okay, so the first thing that we want to do is we want to specify a dialect. So in this case, we are using a Postgres database, so we're going to specify Postgres. You do have the ability, if you want, to use drizzle with something like MySQL, things like that. MySQL, great database, but we're going to stick with Postgres in this course because that's kind of our favorite thing to use here on Takeoff. So we also need to add the database credentials here. Okay, so this is going to be that URL that you worked so hard to go get on Supabase. So we're just going to import that environment variable there. Beautiful. Okay, and we have to specify two kind of file outputs. The first thing is going to be the schema. Where does our schema file? Okay, so it's going to be in that database folder inside of that schema folder. Okay, so that is where our schema lives, which is great. Drizzle will automatically pull on all the files that we use inside of that folder. And then we also want to specify where we want our migrations to be outputted. So we're just going to say we want that in db / migrations. Okay, so your code should look exactly like this. Again, this is going to match perfectly with, you'll see, nice, I actually got that exactly equal. I'm pretty happy about that. Don't need to do any editing. But again, you can check out each one of those reference files as we kind of do that live. Okay, so we've got our drizzle file set up. Let's actually go into the fact schema here, because what we need now is we actually need to, if we go back over to Supabase here and click on our table editor, we don't have any tables, right? Which is a problem. We need to set up the table with the vector column support so that we can actually store all of these embeddings that we're going to go ahead and process pretty soon here. So what we're going to do here is we're going to export const facts table. Okay, so we're creating a variable called facts table, which is going to store our table. And we're just going to call this, let's call this just facts. Keep it pretty simple here. And what we now need to do is we actually have to specify all of the different columns that we're going to be using. Okay, so for us, we're just going to use a very basic serial ID column here as our primary key for this table. We're not going to get super in depth on kind of the nuances of SQL. If you want to learn a little bit more about SQL and Postgres and backend systems, we do have our app building course on Takeoff. So that adds some more deeper dives if you're confused on that. And again, if you ever get confused on things, pop into Cursor chat over here, pop into ChatGPT, pop into Claude, whatever your favorite tool is, copy and paste the code and ask questions about it, right? If you need to slow down, slow down. There's no rush here. Learn at your own pace. That's a great thing about Takeoff. You can pause things anytime you like. We record videos for a reason. We don't want to do these live because then, it's more difficult to work at your own speed. Okay, but we're going to create a name column now. We're just going to use the text data type for that. Okay, and this should be a not null column. Don't want that to be null. Content here is going to also be a text column. We're going to name that content, and this should also not be able to be null. Here's where things get interesting. Okay, so what we're going to do is we're going to do a column. We're going to call this embedding here. Okay, and this is going to be the vector column type. Okay, so this is the column type that is enabled with the PG vector extension here. We're going to call that column embedding, and we just need to specify the dimensions that we're going to be using for our embeddings. And in this case, we're just going to use 256, which I'll talk a little bit more about dimension sizes in a bit. And then last but not least, we're just going to do some very basic metadata columns that I like to pretty much typically always add, which are created at and updated at. And those are going to default, which is something that we like to see. So the final thing that we're going to need to do here is whenever you're working with a table that uses that vector column, you're going to want to create an index on that column. So what we're going to do here is we're going to create an HNSW index, which will spare you kind of the details on that just so we can kind of get things rolling. It's just kind of the best practice index to use for the operations that we're going to be using with our retrieval systems. Okay, so we're going to call this embedding index .using, and we're going to specify our index type here. Awesome. And then we also need to specify the operations that we want to allow on this index, which is we want vector cosine ops. Okay, so this is going to allow us to do all of kind of the similarity search things that we're going to need to do once we get into our retrieval steps. Okay, so this is effectively every single thing that we need. You'll actually see I'm importing a few things. I use an auto import system here. So we actually have to make sure all of this is getting imported from PG Core. Okay, so again, if we go back to that reference code, click on the fact schema here, you'll see it. Oh, this is a good reminder. This is why the reference code is so helpful. I actually forgot to do the typing here. So let's jump back into the file here. We also need to export these two types, the insert facts and the select facts, because these are going to give us the ability to use types cross replication, which we really like. Okay. So at this point, we have our facts table built. We have support for vector embeddings with a dimensions of 256. Again, dimensions, if you watched the last section, which hopefully you did, otherwise you're going to be a little bit lost. Dimensions are just going to correspond to how many numbers are in the actual vector that we get back from our embedding model. So last but not least, let's actually just jump into the index.ts file here. Again, that's just going to live inside of the DB folder here. Let's close up the reference code inside of that DB folder here. And this is just going to define a few things about our actual database. So we're going to need to actually import we're going to speed through this a little bit because this is mostly just boilerplate code that's not anything that you typically need to worry too much about. This is between all of your different projects, mostly going to be the same. So what we're going to do here is we're actually going to specify our DB schema so that we can use Drizzle's query language, which is kind of nice sometimes. It allows you to use very nice Drizzle API for doing things like queries and selects and inserts and things like that. So you don't have to write raw SQL, which is really awesome, especially if you're somebody who works with TypeScript quite a bit, which we definitely do on Takeoff all the time. And then we just need to initialize our DB here with some of those parameters. Okay, so we need to create a client here, and that is going to be a Postgres client, which we import from the Postgres package that we installed at that npm I step that we did a few minutes ago. Okay, we're going to use prepare false. This just has something to do with how Supabase works. And then what we're going to do is we're going to return an instance of Drizzle here with that client and with that schema that we specified with our table here. Again, if you really want to learn more about backend stuff and how Drizzle works and how Postgres works, go watch our app building course. We have all these sections on backend development there. It covers these things much more depth. But this is going to be very sufficient for now. So as long as you have this Drizzle config file, this index file here in your DB folder, and your fact schema so that we can actually get that table defined with the support for embeddings. Really quick, guys, I made one little typo that I just want to make sure that you change before we move on here. I accidentally wrote cosine ops, so I had consine. Make sure that is just cosine ops. Again, this file should match directly with the file that you find in the reference code. So if you want to make sure that that's going to work properly, you could even just copy and paste that guy. But once you have the fact schema, the index.ts file here configured, and your Drizzle config, what we should be able to do is we should be able to do npm run db generate. This is going to generate the SQL migration file that we need. Okay, you can see I'm looking at the reference code. One thing to make sure you're paying attention to is don't don't mix the reference code and your code. Okay, so I accidentally just clicked on the wrong file. So if I click down here, you'll see that we have our newly generated SQL file. And what we need to do is, okay, and one of the cool things about Drizzle, right, this is kind of why we use it, is Drizzle is taking this TypeScript code that we wrote here. It's allowing us to have type safety across our project, and it's generating the appropriate SQL. But one thing that we need to do, again, because we are using PG vector here, is we actually need to do create extension if not exists vector, because this will actually unlock the ability for us to use that vector column type inside of Postgres. So if you don't actually add this line at the top of that generated SQL file that you just got, you're not going to be able to have support for embeddings, which is just going to break everything, okay? So once you have that SQL file generated and you make that addition here at the top, what we can do is we can do npm run db migrate. When you run npm db migrate, assuming that you have correctly entered your connection string with the password in that .env.local file, you're going to be able to get the success message. And if we navigate back to our Supabase database, you'll see we now have a table called facts. We have all of these column types, including that vector column type that we named embedding. And so you should be all ready to go. At this point, your vector database is 100% set up, and we are all ready to roll and get this RAG system actually built. Let's jump right into getting some embeddings generated with the OpenAI API. So you should, again, already have your API key set up and entered in that .env.local file because you're going to need that in order to proceed here. So we're going to go about this in 2 steps here. The first thing that we're going to do is we are going to set up a little bit of a clients file, and then we're going to do our generate embeddings file. As a quick note on the structure of how I've kind of set up the reference code folder here is I've added kind of prepended everything with numbers so that things are a little bit easier to follow sequentially here, which we're going to be doing down here in your code as well. So the first thing that we're going to do is we're going to create a file called 0-api-clients.ts. And what we're going to do here is we're just going to set up the OpenAI and the Cohere clients with their respective SDKs that we installed at the very start of the section so that we can just use those in all the different files that we're going to be using them in because we're going to be using them quite a bit here. So let's go ahead and get that set up. So we are going to need to set up the config here. Again, this is something that you'll get quite familiar with the more that you write code. But basically we're going to again, I have auto import set up, so you may need to type those yourself. You'll see, again, I'm going to continue to use cursor tab here just to make sure that this is sped up. But basically what we're doing here is we're configuring where our environment variables are coming in, which matters because we need those API keys for the OpenAI API and for the Cohere API, which we're going to take care of down here as well. You'll see this actually hallucinated just a bit here. Actually, let's actually go check the reference file. I can't remember if that's the correct package or not. Okay, so it looks like it is. We just need to make sure that we get that import for the Cohere client. Okay, so you're going to have the OpenAI client set up as a variable that you can access throughout this section here, as well as the Cohere client here that we can access. Again, OpenAI uses that API key syntax, and Cohere uses the token. Okay, so we're just going to make sure that those API keys are correctly importing from our .env.local file inside of this folder. Okay, and once you have those API clients set up, what we're going to do is we're going to create another file, and we're going to call this 1-generate-embeddings.ts, and this is where we are going to start to write the code so that we can take our text, get it embedded, and then in the next section, we'll actually be able to get embeddings rolling, and we can get some data populating inside of our SQL table here that we made. So again, we're going to be using the OpenAI embedding models. We're going to be using their text embedding 3 series of models here. So OpenAI has really good resources. We referenced this in the previous section already. You can check out all of the great documentation that they have here with all the different examples and their API reference if you want to see some code directly here. But what we want to do here is we actually want to write the code that we need in order to generate embeddings. Okay, so what we're going to be doing is we're going to be writing a function here called generate embeddings. Okay, we're going to be using this frequently across all of these files. This function, we're going to have take a single argument called text. You could call this data, you could call this documents, but this is just going to be an array of strings that we're going to pass to, you'll see I have a typo here, that we are going to pass to the API. So let me get rid of this code. I actually cursor tapped this in here. Okay, so we have the single function here called generate embeddings. Again, you're going to want to make sure you export that so that we can use these across all of our different files coming up here. And then we have the single text argument. So inside of here, we're going to create a new variable called response. And we are going to save this to the OpenAI embeddings response. Okay, so we're going to access that OpenAI client. You'll see we are getting that auto import here, which is great. This is a cursor tab thing. Again, cursor is just the best, guys. I love cursor so much. But what we're going to do here is we're going to use the embeddings endpoint. And we're going to use, let's see, it's create. I'm trying to do this off my memory a little bit here. Sorry if I make a couple typos here. But what we want to use here, and I'll talk more about these parameters in just a sec here. We're going to use, again, we're using those text embedding 3 series of models here. Okay, we're going to use the small one, so it's a bit cheaper here. We're going to use those 256 dimensions. Again, we set, that's what we set up here in our SQL table here. So those values do in fact need to match. You can't change your mind here. If you were to change your mind, you'd have to go and redo those. Otherwise, you're going to run into a whole host of errors. And then as our input into the model here, we want to pass in that array of text here. Okay, so that's going to go embed all of those, the various array of strings here that we give it. It's going to grab the embeddings here. And then what we want to do is from that response, we want to grab response.data. We are going to map over that data, and for each item in the array that comes back, we're just going to return the item with its embedding here, okay? Now I'm going to import that again. You're going to want to make sure that you import that directly from this API clients file. Make sure you import it directly from the one that's in this same folder here. If you use like an auto import system, it may accidentally import the one from the reference code. So make sure, again, we're just using our file inputs or our directory structure. We're just going up directory here. We're using the file from the same directory. Sorry guys, I've been recording for a few hours here. Starting to lose my mind a little bit here. But what we're doing is we're importing the OpenAI client here that we constructed in that previous step here. We're using it here. We're saving the response from the OpenAI embeddings API. Okay, we're using the text embedding 3 small model. We're using 256 dimensions here on those embeddings, and we're passing in our texts, and then we're just returning the embedding back. Okay, so why are we using this model, and why are we using this dimension size? So let's finally actually talk about that for a sec. So OpenAI has 2 embedding models in the text embedding 3 series. They have small and they have large. So small is the faster, smaller model, right? That's why it's called small. A larger one is the larger, but slower and more expensive model. So the cost difference between the two is the small one is going to be a little bit over 6 times cheaper to use. The advantage of using the large embedding model is that when you're performing retrieval steps, the large one is actually going to be more accurate. So you're basically going to get more data encoded. I'm trying to simplify just a little bit, so some of you who are highly technical are going to get a little bit mad at me. But basically, think of it like this. The small model isn't as good, but it's significantly cheaper. It's still really good, just to be clear. When I say it's not as good, it's a comparison thing, right? It's still a very good model. The text embedding 3 large model is a bit better, but it's going to be a lot more expensive. So if accuracy, things like that are absolutely vital to what you're doing, you want the absolute best in class, you're going to want to use the large model instead. Maybe you're fine with paying the difference. That's great. Use large. We're going to be using small in this video because we want to make sure things are as cheap as possible for you guys. And what we're doing, we don't really need to worry about the results. Also, with dimensions, the smaller the dimensions, so you can actually see the range in the OpenAI docs here. You'll see this might actually be something you have to go to the embedding docs here. I can't remember what the dimensions top out as. There is an upper limit. Okay, so it looks like, yeah, you can see here in the docs. Again, this is why you read docs, guys. They have a lot of good information in it. But the default for small is 1536, and for large, it's 3072. Okay, I can't remember what the upper bound is, but you can go ahead and check out the link that I have below for you guys if you want to get into those details. But when you're working with vector databases, the larger dimensions, it just takes more, you're storing more data. Okay, so you need, you're using more resources on your database, which is going to be more expensive. It's going to be slower. Okay, so if you use the minimum, which is 256, you're kind of optimizing your database to be a bit cheaper, significantly cheaper at scale. So if you are someone who's building a retrieval system that's going to handle a pretty large scale, maybe you have a ton of users, a ton of vector embeddings that you're working with, just know that the higher that dimension count is, it's going to really affect the resources that you need on your vector database. So for example, when we set up our Supabase project, we had that micro scale, right? We had kind of the smallest computer, just to keep things simple here, that database was running on. If you're using a very high dimension count, you're typically going to need more memory on your database and whatever server that's running on. So you're going to kind of need to pay more for that kind of system. So that's why we're doing 256 and using small, because then we don't have to worry about those problems right now, and we still kind of get all the core concepts drilled. So I know that was a little bit technical and maybe a little bit more info than some of you needed, but just kind of wanted to address that. So if you are somebody that's really trying to scale these systems, obviously you're going to want to talk to people and maybe consult a bit about those decisions. And obviously you can use a bunch of different embedding models. We're just using the OpenAI one here to keep things really simple. Okay, so if we actually test this out, what we're going to do here is we're going to create a little asynchronous function here. We're just going to call this main. Again, I might need to take a little bit of a break from typing, guys. I'm having some troubles here. We're going to create a function called main here that we're going to run just to make sure that this is all good to go. And what we're going to do is we're going to generate embeddings. We're going to just test one embedding. We're just going to say hello world, so we'll embed this text and get a result from it. We're going to log that, and then we're going to, at the very bottom of this file, invoke this main function here. So what we can do to run it is if I right click on generate embeddings here, we can copy the path here, and if I do tsx space in that file name, this is going to run that file, and assuming you've set your API key all up correctly and have all of this code written, you should get all of these numbers here. Again, that's a vector embedding for the hello world text here. Okay, so this is the generate embeddings function. At this point, you have kind of learned what some of these, the model and the dimensions, what they are, why they matter. We've written this function so that we can use it as we go out through these other sections, because we're going to be generating a whole bunch of embeddings as we go about this. And then we've verified that that works, okay? So we're going to be building off of this, so make sure you don't really skip any of these, because each one's going to kind of build on the next one until we get to the very end here. One quick note before you move on to the next lesson, though, is you are going to want to comment this out so that you don't run this code as we kind of import it. You'll see in the reference file, I say uncomment to test, then comment again. Okay, so the idea here is if you want to test the file, you can run it just like how we did below with the TSX thing. That's TypeScript execute. And then once you're done, you're just going to want to comment back. Okay, again, we have the reference files for everything so that you can make sure that your code matches the one that we have as the example for you, so you can make sure that things actually run correctly. We've obviously verified all those files work. But let's go ahead and move on. We are now going to get into uploading and embedding your data and putting it in your vector database. Let's actually go ahead and start working with our mock data and get all of these pieces of information, all of these little facts here embedded and inserted into our vector database. So what we need to do now is we actually need to build a new file here that we're going to use the generate embeddings function in. Okay, so we're going to create a new file here. We're going to call that upload-data.ts. I'm going to continue to prepend those with the numbers to keep things nice and organized here. And so what we need to do is we need to take all of the data here. So each one of these facts, you can see this is an array with 100 objects in it. Each one of these objects has two properties. We have a content property, which is the fact that we want to embed. And then we also have a name, which is the name of the animal that it corresponds to. Okay, we're going to be using that name when we get to around to the metadata filtering section here. Okay, so let's jump back into our upload data file here. Okay, so we're going to go ahead and all of these functions are very similar. We're going to be making a bunch of asynchronous functions that we're exporting. Again, we're going to be building off of this and using each function that we write in future lessons here. Okay, so again, we can name this anything we want here. Let's just name, I think we named it docs in the reference, so I'm going to keep it consistent here. The docs are going to be an object that have a string and a name that is also a string. And this is going to be an array. Okay, awesome. So this upload data function takes in a single parameter, which is just an array of documents here that match the data type that we're using in this mock data array. Okay, great. So what we'll do eventually is we'll actually just call this function. So what we're going to do here is do another async main here. Again, you're going to want to comment this after we run it, but we'll get to that near the end of this lesson here. And eventually what we're going to do is we're going to run the upload data function with this mock data. Okay, and you're just going to need to import that mock data array. And so what we'll do once we get the code written for this function, we'll run this file, and this will actually get all of our data inserted into our database with the embeddings. Okay, so that being said, we actually need to generate the embeddings here. So we're going to create a new variable here called embeddings. We are going to save that to the result of the generate embeddings function that we used here. Okay, and we just need to map over our docs here. We need to do, let's see, doc to doc dot content. We're actually going to change this from docs to doc here. Again, the reason we're doing this is because in our generate embeddings function, remember, we take a single array of strings called text. Okay, so in here, we're just keeping the data type consistent with the mock data that we have, but we're actually only using the content property in our generate embeddings function because the fact itself is what we actually want to get embedded, right? It doesn't do us a ton of good to embed the name, right? That's just gonna, all of these embeddings would be the same, right? So we want to embed the fact, which is in the content property here. Okay, so we're going to run upload data. It's going to generate embeddings off all of these facts here. Again, we're just passing in that to the function down here. Okay, and that's going to save the embeddings to this embeddings variable. And then we need to take all of that data and we need to actually insert it. So what we're going to do is we're going to do db.insert, okay, and we're going to insert onto that facts table, okay, and the values. Okay, so we're going to go dot values here, and this is going to allow us to define the values here. What we're going to want to do is we're going to want to take the object that we got back from the OpenAI response. Again, that's going to contain all of the embeddings that we need. And we're going to want to do probably two things here, which we want to grab each one of those embeddings, and then we also want to grab the index because we need to use the index to get the information off of these docs here. And what we're going to do here, okay, is we're going to return an object here that has that embedding as one property case. So that comes off of the OpenAI API. That's the entire point of sending it through that model. And then we're going to grab the doc at each index with its name. And then we're going to grab the doc at each index with its content. Okay, so what we're doing in the step, okay, and of course we need to import the DB from our database setup that's coming from this index.ts file. Okay, remember we exported that DB with that little setup we did there in a previous lesson. So let's run through what's about to happen and then we'll actually run the code. Okay, so we're going to call this upload data function. We're going to pass all of our mock data here, which again are just those facts with the content and the name. There's 100 of them. And what we will do is we will generate the embeddings with the function generate embeddings. Okay, that's the one we did in the last lesson. And we're going to take the embeddings, upload that to the database along with its name and content. Okay, so we're going to be adding those 3 different properties and inserting that into our database. So what we can do, again, we can copy that path here, tsx paste that file path in, and what you should get is we're going to have to wait a second, of course, because this is an asynchronous operation. It's going to upload our data, and what you'll be able to do here, so we go to our database, hit refresh here, you'll notice, boom, we now have 100 records in our database. You'll notice a few things. We have the serial ID that's generated automatically. We have the name. Oh, you know what? I actually made a mistake here. Let's go ahead and go back. You'll see on content, I did .name instead of .content. So maybe this is actually helpful in case somebody does this wrong. So let's go ahead and make that change, and we're going to save it here. And what you can actually do is if you click this button, this is one of the great things about Supabase, is not only do they make it really easy to get set up with a Postgres database, but they also have all sorts of really nice GUIs, all sorts of UIs for working with your data. So what we can do is just select all those rows. We're going to delete those. Hopefully you caught that spelling or that little bug I had before you ran this. But if I hit Control-C here on Mac, we can run this again. And this time we're actually going to get our content uploaded. So we should hopefully, again, I'm going to refresh this here. You'll see because our serial IDs are starting from 100 or from 101 instead of 1. Those are going to be a little different, but you can see we have the name, we have the content, we have that embedding stored in that nice vector column type that we get from PG Vector. And then of course we get created at and updated at automatically because of how we set up our schema earlier. Okay, you can see we got the default now. So when we insert, it's going to default to whatever the quote unquote now value is. So at this point, we have all of our facts embedded, all 100 of them. You can see we have the 100 records there. We have the embedding done correctly. Just to verify, I am using content up here and not name, like the mistake I made here. But everything looks good to go. The last thing we're going to want to do is just comment this out so that this won't run in the future. So we now have our data uploaded. We have all of those embeddings generated along with it. We can now get into doing the next step, which is going to be doing a very basic retrieval. So let's go ahead and jump into basic retrieval. Next, we're going to tackle basic retrieval. Okay, so we're going to do the most basic common type of retrieval that you're going to be doing with embeddings, which is very basic similarity search here. So let's just go ahead and jump right into the code here. We're going to create file 3 this time, and we're going to call this retrieve-data. Okay, so now we have retrieve-data. So in this file, we're going to be doing another function here called retrieve data. And this time we're actually going to accept 2 parameters, not 1. The first parameter is going to be our input, which is going to be a string. So input is going to be equivalent to whatever the user query is that we're using. Okay, so for example, in this case, we could ask a question about, I think the theme that we're going to be using is like elephant questions. So, if we said what do elephants eat, right? That's going to be our input. And the reason that we need that is because we're eventually going to need to generate the embedding for the input. Compare that against the records that we have in our database, right? We need to perform similarity search between that input and all of the embedded values that we have in our vector DB. Okay. The second argument that we're going to use here is options. Okay, and these are going to be a few optional parameters that we can use to help our query. So we're going to do a limit, which is going to limit the amount of results we get back from our search. We're going to do a min similarity. So this is going to allow us to optionally, I need to add a question mark here to make that optional. So we can optionally filter by a minimum similarity score, which is something that can be useful, right? Maybe you only want documents that are extremely similar to your query. So that's a good way to filter some of those out. And we're going to also do name, which could be string or null, okay? Or null, and we're going to default options to an empty object here. We're going to revisit the name once we get to metadata filtering here. So we probably won't come back to that for a bit here. But what we want to do here is we want to do what's called destructuring. So we're just going to grab these values off of that object and set some defaults. So by default, we'll accept a limit of 10. Okay, so we're going to get at least 10 facts every time unless we specify otherwise. For our minimum similarity, let's do like 0.3. Okay, so we're only going to accept records that have a similarity score that's computed to be above a 0.3. and we'll default name to null. And of course we have to grab that off of the options object here. Okay. So now we can actually get into the first step here, which is that we need to generate the embedding for our query. Okay. So again, we're going to use our good friend here, the generate embeddings function here, and that is going to be an array with a single value here, which is just going to be that input. Okay, so we're only going to be generating one input here as opposed to all of the inputs that we were generating with all of those the uploads. Okay, and again, you're just going to continue to import these from the files that we've been using. So once you have the embedding for that, you can actually calculate the similarity. Okay, so we're going to create a new variable here called similarity. We're going to do a SQL type here. We need some backticks here, and this is going to be 1 minus, okay, so if you watched the previous section here, you're going to remember that we are now trying to compute cosine similarity between our input and the records in the database. Okay, and to do that, we're going to take the cosine distance function, right? And remember, we get this for free from the Drizzle ORM library, which is super convenient, and this needs to take in 2 arguments. Okay, we're going to take the column. Okay, in this case, it is that facts table.embeddings. Again, facts table is going to be imported from our, if I get this import working here, facts table is going to be coming from our DB schema there. And then, of course, we need to compare that to the actual embedding, which in this case is just going to be the first item in that index. That's why it's complaining it had an extra S there. Okay. Remember, with code, syntax matters, spelling matters. You got to get those characters right. But what this is going to do is this is going to calculate for the that vector column. Okay, so it's going to take our embedding query. It's going to compare it against, for example, this first fact here against this first embedding here, and it's going to compute a similarity score for one of these records here. Okay, and then we can use that for similarity search here. Okay, so what we're going to do here now is we're actually going to fetch our documents. Okay, so we're going to do a little bit of a query here. Okay, so there's going to be a few things going on here. First, we need a select. This is a SQL select operation. Okay, we want to select the name, factstable.name. We're going to do the content, factstable.content. Okay, that's just specifying the content types, or the column types rather. We also want to get the similarity scores back. Of course, this is Drizzle syntax with kind of SQL queries if you're not familiar. So if you are familiar with SQL, you know, some of these are going to sound really familiar, right? We're going to select from, right? Select from facts table, where. Okay, so this is the where clause. And this is going to be a little bit tricky here. So we're going to conditionally do where clauses based on if name is null or not. Again, we're going to come back to what we're doing here when we get to the metadata filtering section. But for now, if name has a value, okay, so if name is identified, if we're doing metadata filtering, we want to compute the similarity with the minimum similarity here, okay? And then we want to do a little bit of fancy syntax here. This is just going to help us handle case-sensitive values for our comparisons, which will make sense once we get to the metadata filtering section here. Again, you're going to want to make sure that this is written exactly how I'm doing it here, just because syntax does matter with this query stuff. So if you need to go check those reference files to make sure that you're all good there. And so what this question mark means is basically if name has a value, if it's not null, we want this to be our where clause. Otherwise, okay, so this is what the colon represents here. Otherwise, we just want a GT. GT just stands for greater than, if you were wondering what that's all about. Okay. And so you can see greater than, you can see hovering over it here. And it's just going to test that the first expression passed is greater than the second. Okay, so the reason we're giving it similarity here is because that's the similarity score. And then we're just making sure it's greater than the minimum similarity. Yeah, once again, I did an S there. Gotta stop doing that. Okay, so we have our where clause. Let's do a basic order by here. Okay, just because we want to order the results here by the similarity score. Okay, so we're gonna go highest similarity score to lowest. and then we're going to limit it by whatever the limiting value is. Okay, again, remember the default there is 10. The minimum similarity score by default is 0.3. And then once we have all of those documents, we can just return that. Okay, so again, I gotta make sure I'm spelling these things right. Okay, so let's just really quickly, before we actually run this code, let's go over this one more time. Okay, so we created a retrieve data function, takes two inputs, or takes two parameters into the function. Okay, it's going to take that user input. It's going to take our options here, which is an object. There's a few different values. We're going to grab those values or set the default ones. We're going to generate the embedding for our input. We're going to take that input and compute similarity scores across our table. Okay, again, our index that we set up when we built the SQL migration for this is what allows us to do this kind of at scale very efficiently, which is great. Love cosine similarity with PG vector. Super useful, super nice. Okay, and then we're just grabbing the documents. Okay, we're grabbing the name, the content, and the similarity from the facts table where the condition is met here, ordering it by highest to lowest similarity, and then we're limiting it by whatever this number is here, by default 10, or the one we specified here. Okay, and what we can do here is we can do another async function main here. So in this case, we're going to do const documents equal await, and then we're going to call retrieve data, and I'm just going to do tell me about elephants. Okay, tell me about elephants. So we're going to compute the embedding for this, compare it across all of our different 100 records here, and figure out what the 10 most similar are, assuming that they are all above at least 0.3 here, and then we'll just log that here so that we can actually see that. We're going to call that function right below here. And what we can do now is copy that file path and go tsx space file path, hit enter and run it. And if I make this bigger here, what you'll notice is we now have 10 records here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you can see the lowest one is 0.315 similarity score here. Okay, so all 10 of them here are above 0.3. And you can see we're getting the similarity scores computed, okay? So this is what our very basic retrieval step did. It took our query here, which was tell me about elephants here, and it grabbed what it computed to be the 10 most relevant facts in our database. And one of the signs that you know that our RAG system is beginning to work is because look at what the 5 most similar facts are. They're all facts about elephants, okay? And not only do you see they're all facts about elephants, but you can see that the similarity scores here are actually quite a bit higher than these other ones, okay? So you've just done basic retrieval, which is pretty cool, okay? And again, this is what I mentioned at the very top of this section with the really basic data set here. It just is really easy to drive home the points of what we're doing here. You can obviously work with different data. You can work with, huge PDFs and really cram a lot of content in these values and things like that. But it's just really easy to kind of, go through this and make it really clear that similarity search is actually working when we have a relatively simple data set. Okay. So that's very basic retrieval. A lot of people would stop here. But we're not going to stop here. We're going to teach you a bunch of different things that you can use to add on to your RAG system. We want to make sure that you have the most common, the most popular tools available to you in your toolkit so that as you go out into the real world and build all sorts of RAG projects, build these AI projects and tools and all these different things, that you can actually take a basic RAG system like this and build it in a much more advanced way, so that you feel like you are building very competitive tools and very competitive products. Okay, so let's go ahead and start getting into some of those more advanced concepts. Last but not least here, just make sure that you actually comment out the main function again. I'm inserting this. I had to edit this because I forgot to do it. So this is going to come really quick. Just make sure you comment that function out, guys. And we're going to start by going into query optimization. Query optimization is the first advanced retrieval technique we're going to be talking about here. Okay, so we're going to be going over, I think it's like 5 different techniques here. And this is I would say the easiest to implement. It's a very simple process here. The costs are very low, both in terms of latency and in terms of literal dollar cost. You can actually get quite a bit of performance enhancement by doing query optimization here. And so it's one of my favorite techniques to use in RAG systems for kind of my real world tool set here. So let's actually jump back into the code base here. So what we're going to do here, Of course, we are going to make a new file. This is number 4 here. We're going to do optimize query. Optimize, let's spell that right. Okay, so we're going to have this optimize query file here, and we will create a function, and we'll call that get optimized query. Okay, and this function is going to be actually quite simple. This is going to be a pretty quick one. Okay, it's going to take in a single parameter, which is query. Okay, because right, the goal is to optimize that query. And the way that we're going to optimize this query is we're going to directly use the OpenAI API to do it for us. So I'm actually going to help. Let's actually just get writing the code first here. So I'm going to create a new response variable here, and we're going to use the OpenAI chat completions API. Chat completions. Let's see, it's .create here. Okay, now let's feed in those parameters. Let's actually get that import here. Again, one of the things to watch out for, by the way, as you work in these files is if you're like me and you're using an auto import system, it might actually import the OpenAI SDK directly. We actually want to just do the one we initiated in that clients file here. It's going to make our life a little bit easier here. You just got to watch out for the import. We'll use 4.0 mini here. I'm going to talk a little bit about some of the differences and when maybe certain instances you may want a more powerful model. But let's actually pass in our messages here. Okay, so we're going to need a system prompt. So we're going to need an object here with a role of system. Great. And for this content here, I'm going to actually just copy and paste this off my screen. I will make sure to include the prompt below here. Let me just make note of that, include prompt below. So I gotta make sure I do that for you guys. This obviously can be found in the reference file, but I'll have it in the lesson notes as well. Okay, we'll go over this in just a second. We're just gonna do the user message here, and you'll just see it's a role of user, and the content is just going to be our query. Okay, so that's going to be what we actually input to the model. And then let's just take care of the return statement here, which is that we want to return the content off of the message response here. And if for some reason this comes back as empty, we'll just return the query so that we don't return a null value. We need to make sure that we actually return a string, even if it's the query that didn't even get optimized. Okay, so let's talk about this prompt here, and then we'll talk about the model and what's going on in this whole process. Okay, so you can see I won't read this all out, make you just sit here and listen to me read text that you can read. But basically what we're doing is we're giving just kind of a really simple list of 5 guidelines here that is telling the model what we want as the response here. So the idea here with query optimization is if we were to ask a really complicated question, like let's actually just open up our mock data and kind of think through this. Okay, so one of the facts here is that octopuses can regrow lost arms, okay? So maybe we were asking like a really complex question. We were doing some research problem on an octopus. We needed to write a paper or something. I don't know. I'm just making stuff up on the fly here. Okay. But one of the things that can happen is suddenly, your query is like a paragraph long, right? I'm sure, if you use ChatGPT, use Claude, whatever AI app you use, right? Sometimes you can type really, really long queries. Sometimes, take code, for example, right? A lot of the times if we're working in Cursor, right, we're copying, pasting a lot of code. And what happens is those queries get really, really long. And what happens when the queries get really, really long is when you actually go to the step where you're generating your embedding, the information becomes a lot less dense. A lot of extra stuff gets added in there. The embedding becomes more difficult to work with for retrieval purposes and things like that. So what you can do with query optimization is you're almost inputting that full query that we're using, and you're almost trying to get a result that sort of looks similar to what maybe like a search engine request would look like, where the AI, of course, if you read through this prompt, like for example, remove unnecessary words, right? Ensure the query is clear and concise, right? Maintain the original intent, identify key concepts, right? So what's going to happen here, and we'll see a couple of examples of this as we start to use this in some of the upcoming lessons here. But what it's going to do is it's going to try and condense our really, really long query. If we have a really long query, it's going to condense that to kind of the keywords And so the embedding that you end up getting from those keywords as opposed to the full text is going to be much more information dense and accurate, and it's going to it's going to represent kind of what you're actually looking to get from a retrieval system much better. Okay, so it can kind of dramatically improve the results that you get from things like similarity search in pretty dramatic ways just by doing something like this. Just taking your query, using a really cheap model like GPT-4o Mini, basically extracting a few keywords. That's pretty much what query optimization is it's trying to take a really long query and it's trying to reduce that to just a few keywords, a few key phrases so that you get better retrieval results. So a cheap model is really nice for this because it's going to be really fast and it's going to be really cheap, which can be really nice if you're trying to take, a ton of text and just cram it down into a few words or a few sentences, right? It's going to be very cost efficient. And again, the latency matters as well because when you stack a bunch of retrieval calls to different models and things like that, the time adds up. And so, sometimes the user experience can be bad if you chain too many slow things together, right? So that's kind of why we're using GPT-4o Mini. We don't really need a ton of reasoning power here. Sometimes if you do use a better model, right, we were just use GPT-4o Vanilla, what might get a few, the keywords might be a little bit better, especially for really long results, but typically Mini is going to be a model that works just great, right? Like Claude, Haiku, right? That's going to be a great model to use. The Gemini Flash series from Google, right? That's a great model to use, things like that. So we are going to stop here. Actually, let's just run this once just so you can kind of get a feel for what's going on. So we're going to do our typical thing here. We're going to create an asynchronous main function here. And what we'll do here is we'll create a variable called optimized query here. We'll just continue to use this tell me about elephants example for a little bit here. And then if we grab our file path so that we can run this here, let's make our terminal just a little bit bigger for you guys. Okay, you're going to see it takes tell me about elephants and it optimizes that to information about elephants. Okay, so I would probably just prefer, honestly, that this was like elephants. So if we go to, there's a few things you can play around with here, right? It's like, let's try a more powerful model. Let's see what we get. Okay, so this is actually longer. So let's actually just go back to Mini. Maybe if we tweak the, let's like tweak the temperature parameter or something to 0. So it's a little bit more, less creative here. You can see information about elephants again. Okay, so maybe you want to do things like provide examples, right? Maybe you want to prefer just a couple words. It's like use 1 to 5 words. Maybe add a new rule here. Lean towards shorter queries here. Okay, maybe we try this again and see if we get. Okay, so now we just get elephant information. Okay, so we've reduced that a little bit. So you can kind of see how you can sort of play around with the system. I'm just going to revert this to what it was just to match what that reference file is here. So let's get rid of temperature here. But I think you can kind of see there's a lot of different ways you can play around with query optimization, and it's kind of up to you how you want to do it. And you're going to kind of want to evaluate it in the context of your full RAG system. But I think that's probably a good stopping point for this video. The point is that when you take a really long complex query, reduce it down to a few keywords, you can get better retrieval results. And this is really all you need to actually implement that. Okay, so we'll see that in use in future lessons, but this is kind of all we need to actually get this thing working. And let's of course make sure that we comment this code out so that we can move on to the next advanced technique here, which is we're going to use the Cohere API to do document re-ranking, which is a real cool one. In this lesson, we're going to be learning about how to use document re-rankers to rank your retrieval systems to actually continue to add advanced retrieval techniques to your RAG system. Okay, we're just at this point stacking performance gains on top of each other here. So we're going to be using the Cohere API here. So hopefully in the earlier lesson, near the start of this section, you actually went ahead and got your Cohere API key. If you didn't for some reason, just make sure to go to the Cohere dashboard once you've signed up, go to that API key and make sure that it is in your .env .local file here. Okay, make sure it's in there. And you'll be all set to go. So what we're going to do here is we are going to create a new file here. We are now on file 5, and we're going to call this rerank documents.ts. And what we're going to be doing in this file is we are going to be utilizing Cohere's Rerank API, okay? So what this is going to do is we are going to take our basic retrieval process and we are going to further optimize those results by using another API endpoint, okay? So we're going to be doing similarity search and then we're going to be doing document re-ranking. There are different ways of doing this. Some people prefer to do it in different orders and things like that. I really like doing retrieval, basic retrieval, and then doing re-ranking after. That's probably the overwhelmingly more common scenario to see. But basically what this endpoint is going to do, okay, so we're just using Cohere's V2 API here. And what we're going to do is we're going to give a query. It's going to require a list of text. Okay, so in this case, it's just going to be whatever those records we get back from our similarity search from our database our database result there. We're going to pass that query and those lists of texts. And what Cohere is going to do for us is going to rank the documents that we provide it. So in this case, we've been generally doing that limit of 10 records that we get back from the similarity search step. And then it's going to rank those 10 documents. So maybe we want to, run it through those 2 steps and then only produce like 3 to 5 of the most similar. Okay. So it's just another way to get better re-rankings there. So let's actually go ahead and get writing the code for this. Thing about writing the code for this. Okay. We're going to start by just creating a rank documents function here. The great thing about writing the code for this is it's going to crystallize a little bit more what's actually going on here. So if you feel a little bit lost, all good here. The code is going to make the usefulness of this very clear, okay? So this function is going to take 2 arguments, very similar to our retrieve data function here. We're going to take in a query and we're going to take in some documents here. And we're going to make the data type of those documents equivalent to our facts, okay, with the content and the name here. And that's going to be an array here. And we're also going to have a second parameter here, which is going to be a limit of 3. Okay, so I mentioned, one of the great things for re-rankers, document re-rankers, that's kind of say that 10 times, is that you can kind of take a, first pass through with cosine similarity search, and then you get this second pass through to really optimize the document. So you can kind of shave that down to just the most relevant documents and limiting it from, we're going to be using the example of going from 10 to 3. Okay, so we have those 3 parameters here. We have the query, we have the documents, and we have our limit here. So let's actually go ahead and write the re-rank code using Cohere's API. So we're going to go ahead and use the re-rank endpoint here. Okay, and we're going to pass in, again, we need to pass in the texts, and then we need to pass in the query, right? Because you actually need to have something to compare those against each other, right? Okay, so we're going to do doc.content here. Of course, you do need to import the Cohere API from, and you also need to spell it right. Raw rank is not gonna is not gonna be correct, but make sure to import the Cohere client that you set up in the API clients. Okay, so we're finally gonna use that. Okay, we need to pass query as the second argument. Then we have 2 more arguments. We need to do top n. So this is just going to be the number of records, which in this case is going to be whatever our limit was. Okay, so in this case, we're going to be using 3 by default here. And then we also need to specify the model, which we are going to be using Rerank English-v 3.0. Okay, that's all we need to get the re-ranking results back from the Cohere API based on our query and the text, the list of text, which is going to come from those facts from our records that we get back from our cosine similarity step. And of course, we just want to return those. So I'm going to go over this kind of quick here. We'll just use cursor tab there. So we want to get the name back. We want to get the content back. And then we also want to get the relevant score, which is how the Cohere API is going to re-rank things for us. Okay, that's going to be the score that we actually get from that API. So in order to test this, we need to make a little bit of a main function here. And of course, we'll call that right below there. And let's go ahead and create a variable called retrieved docs. Okay, so in this case, we are going to do step one, which is we're just going to be performing good old similarity search. We're going to be using this retrieve data function that we've already taken the time to write. Of course, we need to await that. This is going to be retrieve data. Okay, and we'll just stick with tell me about elephants. Of course, you need to import that from that particular file here. Then once we have our retrieve docs there saved as that variable, and remember, we're just getting that back as return documents. Okay, that's how we have access to that. What we're going to do now, okay, is we're going to create a variable called documents, and this time we're actually going to pass our retrieve documents into the rank documents. Okay, so first things first, we need tell me about elephants there. Again, we're reusing the same query here, and then we need to pass in the docs, right? The docs that we got back from that retrieval step. And then what we'll do is, of course, we'll console log those documents so you can see what this API result looks like. Okay, so let's go ahead and copy that file path and get this thing running. I'm gonna run a clear here just to clear that up just a little bit. And what we should be able to find is that we get an array of 3 records here. Okay, so you can see we're getting the name, we're getting the fact, and then we're getting the relevant score that's coming back from the Cohere API. Okay, so here's basically what's going on. You know what? Actually, I'm going to log the retrieve docs as well so you can kind of see how this was whittled down. Let's do a little Control C here and run that again. Okay, let's make this big so I can really drive home the point here. So this first result that we're going to get, this first array here, is going to be those original 10 records that we got back just from our similarity search. Okay, so we already kind of saw this result in a previous lesson when we actually tested the retrieve data function for the first time, right? We got all 5 of the elephant facts here, and then we got those 5 other ones, right? You can see we got giraffe, rhinos, even a dolphin snuck in here, okay? And you can see those came with similarity scores. So what we're doing here with the Cohere Reranking API is we are passing in our query, which was tell me about elephants, and we're passing in all of the list of documents here, except we're just grabbing that content property just to simplify things. And what Cohere is doing is it is ranking these all the way from 1 to 10 based on the relevant score that they compute, and it is returning us the 3 most similar facts. So you can see if we compare these 2 lists, you'll see that the very first result here, elephants are the only animals that can't jump. Okay, that's actually ranked the 4th most similar in our similarity score, and this jumps all the way to number 1 when we add a re-ranker. So you can see the re-ranker must have done a pretty good job here because it kept all of the elephant facts here, which is definitely something you would expect. And this query isn't, I probably should have done a better example, to be honest, to really drive home the point here. Like let's go look at our mock data here actually, and let's do one more little example. Let's see, we could do like, could we do something cool with like penguins? Okay, there's a few questions about sleep. Like let's try something with sleep here. Let's actually just change this query here to, I want to learn about animal sleep. Okay, and let's run this one more time. Okay, I'm gonna go Control C, run this again. And we can just see like one more example here of what's going on. Okay, so what's interesting is we're actually not getting 10 records back, which tells me that if you remember back to our retrieve data function that we wrote, we had that default 0.3 similarity score. So already by using a minimum similarity, we're probably already cutting off a few records, which is actually really good for a retrieval system, right? You're basically setting a hard line of we only want things that are X amount relevant. Okay, so we got these 6, and then we cut it down to these 3. So you can see again the order here shifted around a little bit. So you're going to see as we get to more examples, especially in the next section when we do like a production grade system on some more complex data sets, re-rankers can really drive home a lot better results. The re-ranking API from Cohere is quite cheap. So you can actually get a lot of performance again for pretty low costs. So that's how you go about the re-ranker here. We'll comment out this code as we've been doing, keep making a habit of that. But this is going to become more obvious why this is useful down the line. So stay with me here. Next is going to be our next advanced technique, which will be metadata filtering. So we'll finally talk about why we were using the name in this example the whole time. It's time to finally get into metadata filtering. So what we're going to be doing in this lesson is we're going to be using OpenAI function calls. Okay, so we're going to be using LLMs plus function calling to add additional queries or additional where clauses to our queries when we search. So the best way to demonstrate that is to just kind of jump right into it. So what I'm going to do here is I'm just going to kind of clear what I was working on here. And let's just go ahead and create our new file. We're going to call this filter-metadata. Okay. And what's going to happen here is we're going to basically build a little name extractor with a function call. So if you're not familiar with function calling in kind of the AI world, we'll kind of also teach you that as we do this here. So what we're going to need to do is we're going to create a new asynchronous function. And we're just going to call this extract name, and it's going to take a single query parameter, and that's all we need for this function. Okay. So we're going to do a few things here. We're actually going to make a call to the OpenAI API. Okay, so we're going to use our good friend, the chat completions endpoint here to do that. And we need to do a few things. So per usual, we're going to use GPT-4o Mini. For messages, we're actually not going to use a system message. We're just going to use a user message here with the query. This is going to be a really, really basic call here. And we also need to add the tools parameter here, which is going to be an array of tools. And I'm going to go ahead and just copy and paste the tool that I have right here so that we don't have to type all this out. I think I mentioned this in the last lesson or maybe the one before that, but you want to make sure that you get that import correctly. You want to import the client that you made, not the OpenAI package directly from its library. So what we're going to do here, and actually let's just do one more thing here, which is that as part of tool calling, you actually need to parse your tool call, which I'll just auto-complete that right there. And then we want to return either the parsed tool call or a null value here in case we actually don't have a name entity. Okay, so let's actually back up for a second now that we have this code all written. And let me explain a little bit what's going on here. Okay, so we're using GPT-4o Mini. We're sending a single message to OpenAI's chat completions API with that query. And what is going on here with this tool? Okay, so as you can see here, we have defined a function call. So a function call is basically the ability for an AI model to recognize, hey, I have access to a bunch of these tools. When should I use this? So, one of the most common tools you'll see used in the AI world to kind of teach function calling is like a get weather function here, where we're gonna, function calling is not the point of this video, so I'm just gonna kind of go a little bit quickly here. But the idea is, say you had another tool in here that was get weather, and you asked a query about the weather. Well, the model's probably gonna know, hey, I gotta call the get weather function, and the schema that you define here is going to define what the model actually returns as part of that tool call. So in this case, we have a filter by name function here. You can see we have a description here, which is getting passed to GPT-4o Mini as it works. And so it's almost kind of like the prompt for this specific function call. As you can see, we're trying to extract the name of the animal or entity from the query. It must be the full name of the animal and plural. Okay, so if I used our I want to learn about animal sleep, right? You're probably not going to get a specific animal there because we didn't ask about anything here. But if we were to use something like tell me about elephants, which we used earlier, what this function call is going to do is it's going to return, because you can see we have a single property here, name, the name of the animal or entity, and that is required. It's going to return the name of that animal, and the LLM is going to kind of reason to figure that out, right? So given a query like tell me about elephants, it's probably going to return elephants, okay? And to prove to you that that's what's going on, let's actually test this thing so that we can see it in action. And what we're going to do here is let's create a query here. Okay, we'll use tell me about elephants. We'll just keep using that one. What we want to do is we actually want to create a new variable called name, and we're going to call the extract name function with this query, okay? And so hopefully we should be able to log this name here and get elephants, okay? So if we actually run this, let's copy that file path, run that in our terminal. Hopefully we should get elephants logging. Okay, awesome. And sure enough, we did, okay? So that's kind of the point of the name extractor here, right? If I did, tell me about giraffes. Okay, we ran this. We should get giraffes back, okay? So I think you kind of get the point there. It's basically trying to extract which animal. So what we can do is, because we built in that optional name filtering here into our where clause here as an optional parameter into that retrieve data function, what we're going to be able to do is we're going to be able to pass the name of the animal to make sure that we are only getting the records that are relevant for that particular animal. Okay, so let's go ahead and actually test that out. So what we'll do is we'll create a new variable called documents here, and we will call retrieve data. Okay, and we're going to call that with our query. And this time we are in fact actually going to use that optional second parameter with the name. Okay, and we're just going to be passing directly that name that we extracted from our function call. Okay, and then if I actually log this out and we run this function one more time, what we should see here is we should see the records for elephants. Okay, so you can see here it's possible. Okay, so interestingly, the model actually gave us a null value, which is kind of interesting. Let's maybe run that again. Let's see if we get the right answer this time. Okay, so we're getting null value over and over and over. So that tells me that we probably could build this out to be a little bit more robust. So one of the things we could do, for example, is try to use a more powerful model. Let's try to use GPT-4o instead of Mini and see if that actually affects things at all. Okay, so it looks like this model is maybe a bit better. Okay, you can see we're getting, it's possible, did I actually make a little mistake there? Oh, I did. Let's fix that. I'm going to save that. You don't actually need to change anything. I think I accidentally hit my key when I was on the retrieve data file. Let's run this one more time here. Okay, cool. So this is what I wanted to get to. Okay. So I don't know why GPT-4o Mini was returning null a few times here. That's kind of strange. Could be that I just need to build a better description here, maybe a better property description here. There's a lot of things you can do on the prompting side of things. Like maybe let's try this out one more time with Mini. This is kind of a good exercise just to see how the underlying model itself can actually wildly influence your queries. Okay. So for whatever reason, Mini's not wanting to work right now, and we don't really want to make the prompting the point of this video. I just kind of want to show you how metadata filtering works. So you can see in this example, okay, we do in fact get elephant scan, and then you can see we're only getting the facts back from our retrieval system, from our RAG system that have to do with elephants, because what's happening, okay, if I go back to the code here, we are extracting the name from this query, saving that name to a variable conveniently called name, and then in the retrieve data function, what we're doing is we're passing in that optional name parameter. And what's happening in retrieve data, okay, to go back a couple lessons here, right? We're pulling off that name here, and then if name exists, so you'll remember we had what's called a ternary operator, which is if this name has a value. Okay, so previously we were just running this greater than here with the similarity score, but now we're running the greater than similarity score that's wrapped in this and function here, this and helper here. And what we're doing is we're checking if facts table dot name, so if the value in the facts table or the value in the column, the name column rather. Okay, so we go look at our database just to make this a little bit more clear, right? We have this name column here with the name of the animal, right? So in this case, it's corresponding to elephants. So it's just getting these records here. It's not actually looking at any of these at all. It's just grabbing the elephants records here, which are really handy, right? Because previously what was happening is we were running some queries that, may only be for a specific animal, right? And in that case, it's going to be completely pointless for us to fetch facts about koalas, right? So one of the things that you can do with metadata filtering is to maybe make this a little bit more concrete for like a real world example is, say you had a bunch of, earnings reports in here, and instead of name, maybe it was company name, right? And maybe you have Google, you have Nvidia, you have Tesla, you have Apple, you have all these different companies. And say you asked a question about Microsoft, for example, right? It's like, hey, give me a summary of the earnings report of Microsoft. Well, one of the things you could do is you could build, instead of kind of an animal name extractor, you could build a company name extractor. And then what you could do is that would pull out Microsoft here, and you would be able to filter by the records that correspond to Microsoft as the company name. So then you're not accidentally pulling in records from, say Apple into your retrieval system, right? So metadata filtering allows you to do all sorts of interesting things to kind of reduce the irrelevant records, right? You can kind of get a little bit more fine-grained queries written, and when you kind of combine that with function calling, it's a really nice way to build these sort of extractors that can take your queries, extract relevant metadata, and then you can use that metadata that you extract to kind of hone in your queries. So this is a really powerful concept that you can use in your RAG systems to help narrow down the results and get you more accurate information. So that is metadata filtering here. We're going to comment out the main function once again, and we're going to go ahead and move on to the next advanced technique, which is text splitting. We're going to keep this section, or this lesson rather, relatively brief, but I do want to touch on text splitting, document splitters, things like that. This isn't a huge problem for the data set that we're working with. Obviously, all of these mock data facts are pretty short, right? So text splitting isn't really something that we're going to need to do. We'll be looking at this a lot more in the following section when we get into longer documents and we have to kind of split things up, because the token sizes are something that we want to manage on these records. But I do want to kind of bring text filtering up just a bit. So let's go ahead and do that. What we're going to do here is we're going to go to your code here, your code, and we're going to create a new file. Let's see, this was file 7, I believe. Got to keep track of where I'm at here. Okay, so text splitting.ts. And what we're going to do here is we're going to just do a very basic split text function. We're not really going to use this. I did mention at the start of the section, if we open up that mock data once again, you'll see we have this elephant wiki. So what this is the second value that we have in our mock data file here. This is kind of a long Wikipedia entry that I had the AI generate. You can see it's several hundred lines here of text. And what we're going to do is we're going to be using that value to kind of test how text splitters work, okay? So what we're going to do is we're going to do export async function here to create a split text function. Let's make sure we get the casing right there. This is going to take in a single parameter here, which is going to be an array of objects that match the data structure we've been working with. Okay, so 2 strings here in that object, content name. And what we need to do here is we actually need to split this text. So before we actually write this code, I'm going to talk a little bit about why text splitters, why document splitters matter. So what happens is when you work with something like the elephant wiki variable here, which is all of this text, right? This is much more representative of, a document that you may work with in a real world setting, right? Say you're scraping Wikipedia or something, you want to build a Q&A bot, Q&A AI bot on all of that Wikipedia information, right? You're going to probably need to break up some of those longer files. So that is where text splitters come into play, is you're kind of trying to do some sort of systematic splitting in case you're trying to split or chunk the particular document up into a bunch of smaller ones to make them a little bit more easy to work with RAG systems. Okay, like I mentioned, we're not going to get too into detail here because this is a rabbit hole. Okay, so if you want to look more into document splitters, you're working with more real world data sets in you're kind of looking for ways to chunk those up into kind of smaller values. For example, a common document splitter is if you're working with a PDF, you might split PDFs based on their page, right? You might only create an embedding for that specific page. So, if you have a 100-page PDF, you split that into 100 different documents and you embed each one of those, right? Breaks things up a little bit nicer. So if you want to go into that rabbit hole, go into it. We're just going to show you a very basic, way you could split based on character count. So let's go ahead and do that. Actually, let's do word count. So what we're going to do here is we're just going to define the content array here, or the chunks array, because we're going to be basically trying to take that elephant wiki and break that up. So one thing we're going to do here is we're going to decide that we want a chunk size of 500 words. So what we're going to be doing is we're going to be feeding this wiki entry into our function, and we're going to be trying to break this up into as many 500 word chunks as we can. So let's go ahead and do that. So what we can do here is we can create a for loop here. Okay, so we're going to iterate over our data that's coming in here, over our data array. In this case, when we actually run the function, it's just going to be one item in the array, right? Because we're only working with one piece of data here. But what we want to do here is we actually want to keep track of the words. What we're going to do here is we're going to do a regular expression here, a regex, which is what this line is here. I'll get rid of that for now. I cursor tabbed a little bit too much there. And that's just going to split the content. Okay, so that content property, it's going to split that by word, right? So if we go back to our data, right, it's going to, I don't need to explain that. You guys get what splitting into a word means. Oh, man. Okay, that's funny. But what we're going to do is we're going to do a for loop here. We're going to loop over those words. Okay, so we're going to loop over words.length. Okay, and then we're going to iterate by the chunk size here. And in here, what we're going to do here is we are going to create a variable called chunk words. We're going to slice those words, and we're going to push those chunks as we slice them into the chunks array here. Okay, so you can see chunk words.join. We're joining on those words. So what we're doing is we're basically grabbing 500 words at a time. Once we hit 500, pushing it into that array and then moving on to the next one. Okay, so what we want to do here at the end is we want to return chunks. I may have done a slight syntactical error here, which is I need to make this an array. Boom. Okay, we got rid of our error there. Now what we're going to do is we're going to create a new function called main. Of course, we want to call that so that we can test this thing out. And now let's take this first bin. Okay, so we're going to create all those chunks. So let's actually run that split text function here. And what we're going to do here is we're going to pass it a array with a single object and the content. Okay, we're going to import the elephant wiki there. We're going to import that text. That's going to be the content. And then, name will just kind of simulate as if we were adding this entire wiki to our database here. What we can do is we can do console.log. We can log those chunks, and let's also just log the length of the chunks so we can see how many 500 word blocks we got in there. And let's run this thing. Let's see how many different chunks we get. Okay, so I'm going to scroll down, do a little Control C so we can reset that terminal, clear that up a bit, and then I'm going to paste in our file name here with TSX. Okay, so it looks like we got 3 different chunks. So it looks like we filled, let's actually make this full screen here, a little easier for you guys to see. Okay, so we got a first full chunk here, we got a second full chunk here. So those are each going to be 500 words, right? That's kind of the point of splitting by 500 words. And then this last one is going to be the remaining words. Okay, so it looks like we didn't quite get to the end of that, right? So this doesn't necessarily have to be up to 500 words, right? Say the wiki only ended, right here at this period, then this chunk would just be really small. It just so happens that this looks like it's approximately 500, so these all look about the same. But the point here is we broke this really long piece of text into a bunch of smaller text, and what we would do is we would then go embed each one of these smaller chunks and upload that into our vector database. Okay, so that's all we're going to touch on text splitting for now. We're actually not really going to use that in our RAG system for this particular example, but it's something that's very common, especially as you get into more advanced RAG systems. And I just want everybody to be aware of it. We'll probably be touching on this more across Takeoff and in RAG related projects and things like that. There's a lot, again, like I mentioned earlier, document splitters are a rabbit hole. But that's pretty much all you need to know for now. Let's go ahead and make sure that we comment this function out. And then we can move on to really starting to get into a full advanced RAG system, right? We're going to put all of the things that we just learned all together so that we can kind of optimize a really nice little production grade RAG system with our example here. So let's put all of these RAG techniques that we've learned and let's put them all together into a single cohesive system. So what we're going to do here, we are going to finally create file number 8 here, which is all together .ts here. Okay, and we're going to put every single one of the techniques, query optimization, metadata filtering, we're going to use our basic retrieval, and we're going to use our document re-ranker, all 4 of those in one pipeline here. We won't use text splitting, but we'll use those other 4 here. So let's go ahead and do that and see how we can get better results here, okay? This is going to be a really nice little RAG system that we've put together. Okay, so this is going to be a function called process query. It's going to take a single argument, which is your original query, and that's it. That's all we need for this to work, okay? So step 1 is going to be using our query optimizer. So let's save that to a variable called optimized query. We're going to use that get optimized query function, okay? And you'll remember that just takes a single argument query here, and then we get that optimized query. Let's also log that out here so that we can see all these steps as we run our function. Okay, so step 1 is getting the optimized query. Okay, that's going to affect everything downstream from this point. Okay, the next thing we want to do is we want to use our metadata filtering to grab that entity name here. So what we'll do here is we will run the extract name function here with our query. Again, that's the only variable that needs to take in. Okay, so we've imported both of those at this point. So we're going optimize query, grab the entity name from the query. Okay, and so now what we can do is we can run our basic retrieval. We can run retrieved docs. We'll save it to that variable here, and we'll call retrieve data. And what we'll do here is we will pass in not our regular query. We will pass in our optimized query. Okay. And we will pass in name, we will pass in that entity name so that we can use metadata filtering to further limit our results here. We'll limit things to 10, and we will we'll actually just get rid of that. We'll just use the default values for that, okay, and then we'll log those out. And lastly, what we want to do is we want to grab the retrieve docs, and we're going to limit these to our ranked results. Okay, so we're going to use that cohere re-ranker. Okay, and again, we have all of these functions here for all of these different points of our RAG process, which is great. Okay, we're going to pass in optimized query as the query to search by. We're going to pass those retrieved docs in that we got back from our basic retrieval step, and we're going to continue. We'll kind of narrow that down to just the 3 most relevant facts there, and then we'll log those out. And lastly, of course, we want to return those ranked results. Okay, so not really having to do anything new here. We're just kind of using each one of those existing steps at different points. And then what we can do here is we can actually test this out, okay? So we're basically stacking a bunch of really helpful retrieval steps, trying to get an optimized RAG pipeline in the works here. This is much more representative of a real world use case. This is what, companies, when they're building RAG systems at scale, they're using all these different steps, right? And there's a lot of little, things that you can do to kind of make sure that the users or your team members or yourself are getting the best retrieval results possible. So let's say I want to learn about animal sleep patterns. Again, there were a bunch of sleep facts in there, the data set that we're working with. And what we'll do is we'll call this process query function with our query here. Query, not weary here. And then down here, we'll call main. And what this is going to do is this is going to allow us to test our RAG pipeline. So let's go ahead, clear our terminal. We'll bring this up just a bit here. We're going to copy that all together file and go tsx space file name, enter. And we are going to see our RAG system at work. Okay, so you can see we got the optimized query. Okay, so it took this kind of little sentence here and it optimized it down to animal sleep patterns here. You'll notice we actually got a null value for our extracted name, and that's fine because we didn't specify a specific animal. We'll try another query next. So we are actually not filtering by an animal in this case, right? That's kind of the metadata that we were filtering on in our example here, right? The metadata value was whatever the value of that name column was, okay? In this case, it's just going to be null. So then we performed a basic retrieval over that. You can see it retrieved 9 documents from that, okay? Maybe it actually is probably going to be helpful here to actually get all of those documents. We'll try that in the next example. And then it fed those 9 documents along with the optimized query into Cohere's Reranker here, and it ranked these as the 3 most relevant facts, which it turned out that we actually got really great results, because if you actually inspect what the facts are, each one of these is related to animal sleep. So instead of getting a bunch of irrelevant information, we were basically able to take our database here of 100 different facts here. We were able to narrow those down to 3 results that are highly relevant for our query, right? Which is exactly what you want in a really high performance, reliable retrieval system, okay? So that's a great result. Let's comment that out and let's just try a different query. Let's use an animal that we haven't worked with. What's another one that we got in here? We could do sea otters. Let's go ahead and try sea otters. What's a fact in here? Let's just try. Can sea otters use tools? Okay, there's a fact there. Let's try. Can sea otters use tools? Can sea otters sea is in the ocean. Okay, sea otters use tools? Question mark. And what we can do is we can do Control C to exit this, and we'll run it one more time. We should hopefully this time actually get an extracted entity, which it looks like we didn't. Which is kind of interesting. That might be something that we want to inspect, right? So we go to extract name. Again, we were running into this problem earlier on that specific lesson. So I think what we need to do is just maybe add a system prompt here, improve that prompt so that, there are always things that you can do. This is why you test your RAG system and kind of, log things out. So then you can see kind of where the weak points are and you can work to improve it. We won't worry about that to keep things relatively simple. But I think you can see kind of as I'm working on this that that's probably a weak link in our RAG system that we'd probably want to go improve. Okay, but it looks like we got a bunch of these retrieved documents. Let's put this up a little bit. Okay, so this is what the database got back. You can see so this is an interesting result. What you can see here is it actually put a few of the octopus facts fairly high. Okay, and so what this demonstrates why a re-ranker is so important, because you can see how the similarity score for this octopus fact is like even higher than the sea otter fact, right? That tells me that whatever embedding that we got back from our do sea otters use tools query here, it looks like, maybe because octopuses are highly intelligent, can solve puzzles, maybe somehow the embedding for that relates a little bit to tools, so it kind of got mixed in with that. So what would happen is if we didn't use a document re-ranker, and we were to limit this to 3 facts, well, one of them is going to be octopuses, which is completely irrelevant to our user query. But when we actually fed that into the re-ranker, into the document re-ranker, you can see that these got re-ranked, and now we only have sea otter facts, okay? So these two might not necessarily be related to tools, okay, like this one is, but it's at least related to the right animal, right? So by adding that additional retrieval step, using that advanced re-ranking technique, we actually end up with better results in our system, okay? So I'm really happy that example kind of played out the way it did, because you can really see why chaining these steps together can actually take your basic retrieval, and actually by applying all these advanced techniques, you can actually get much, much better results, right? This is much better than what we would have got just from basic retrieval. So that's kind of how you can combine all those advanced techniques together to build a more advanced retrieval system. We're going to go ahead and do one more thing, which is we actually want to feed those examples into a chat completions prompt or chat completions call to OpenAI's API to actually get the LLM to actually answer based on our sources, and talk a little bit about RAG prompting and how to kind of effectively use prompts for RAG. Last but not least, certainly not least, this is kind of the entire point that you want to get to so that you can actually get an LLM to give you an answer. We're going to prompt the OpenAI, we're going to prompt GPT-4o Mini to give us an answer based on the results that we got back from our RAG system. So let's jump right into the code again. We're going to go file 9. This is going to be the last lesson. So soak in the RAG system that you just built. Okay, this is pretty cool. You learned a lot here. So very exciting. We're obviously in a little bit of a simple example here, but everything's going to be up from here. We're going to start working with complex data sets and things like that. But let's actually get this thing answering some questions first. So we're going to immediately get right into writing a function here that we're going to call anytime that we run this file here. And what we want to do here is we actually want to go, let's come up with a query here. Let's use that sleep one. I want to learn about animal sleep patterns here. And what we're going to do here is instead of having to do each one of those individual steps now, what we can do is we can actually just import our process query function and pass that directly into here. And what's going to happen when we run this function, and let's actually just comment this one out. We forgot to do that in the last video. What this is going to do is going to run all 4 of those steps that we just put together in a single function here. So it's going to radically simplify what we're going to be doing here. Okay, we don't have to do all of those function calls. We can just do one now, which is great. Okay, and let's actually save this to be relevant docs instead of results, just to be a little bit more clear what's going on here. And then what we can do here is we can actually create a context variable. And what we'll do is we'll actually just map over these docs. And what we're going to do is we're going to use this join helper here, this join method on our array that we create, which is going to populate all of those facts. Remember, each one of those facts is stored on the content property of the document. We're going to join those by 2 new lines to kind of separate those a little bit. And what we'll do is we're actually going to try 2 things. Okay, we're going to start with a really basic prompt here. Okay, and I'm going to have both of those prompts below for you. Okay, so we're going to have both the basic prompt and the advanced prompt. I'm going to make a quick note of that to make sure that I get you guys those resources. So first, we're going to look at the basic prompt. So I'm just going to copy and paste that, and let's take a look at this. So this is basically about as simple of a prompt as you can get. You can say you're a helpful assistant. You answer questions about animal facts backed by facts, about animals backed by facts. Use the following context to answer questions, and then we include the context that we just built with this context variable. That's what we could do here. We're just going to use a new variable called prompt to use to make this a little bit easier to work with. We're going to use that basic prompt. And what we'll do is we'll get a completion from the OpenAI API here. Okay, so we're going to use that chat completions API here. Awesome. We're going to use GPT-4o Mini. We're going to have a messages parameter here. Okay, so we need a role of system with our system prompt, and then we need a second message here, which is going to be the role of user, and that is just going to have the content be whatever our original query was. In this case, it was this sentence here. And then we're actually going to stream the answer, which is going to be a lot of fun. And to stream answers, what we need to do is we actually need to just iterate over the chunks that are being streamed back from us. Okay, so that's going to be saved on the completion response here. And then we're just going to write that to our terminal directly. We're going to keep things really simple and see how this works. Okay, so let's go ahead and actually test this out before we get into more advanced prompting, just to make sure that this works. So I need to go Control C to exit that function. Let's clear that up. Let's make this a little bit bigger while we run it. Okay, so let's go ahead and copy that file path here. We're going to use our good friend TSX to run this file here. And you can see we got the optimized query, animal sleep patterns. Awesome. Okay, so what's happening here in the background is running that process query function, which again, it's just going to take a little bit of time. You can see we're getting that answer streamed in, really cool. So let's go ahead and look at what happened here. So it looks like we got the optimized query. Again, this is not going to extract a name because it was just animals in general, not a specific animal. Okay, we saw that in the last lesson. We got all of these retrieved documents based on the cosine similarity score. Okay, so remember, we're comparing the embedding of this optimized query against the embedding the embeddings of the records that are in our database case. So we're performing those similarity searches there. And then once we have those, we're feeding those retrieved documents into the document re-ranker from the Cohere API, and then it's retrieving us these results, okay? So obviously we kind of ran this example before, but you can see it's working again here. But this time, what's happening is that that is being applied to a response back from an LLM, which is kind of cool. Right, you can see in the answer itself, it's actually referencing each one of those facts, right? The koala, the giraffe, and the sea otter fact, all three of those are being referenced in here. So that's actually pretty kind of cool to see that happening. But one of the things that we want to do is we want to show you how to make some slight prompting tweaks to maybe get some better answers. And this might not matter as much with a simple data set, a simple retrieval. These facts are really small. We only have so many of them. But learning how to prompt for RAG can dramatically increase your results as you kind of get to more powerful systems. So I want to show you a tool that I really like to use. We're going to introduce a new API, which is we're going to use the Anthropic API. Okay, so this is the makers of Claude, the very popular Claude. Obviously, with Cursor, we're using Claude 3.5 Sonnet still, as of the time of recording this. Claude 3.5 Sonnet, the new updated version, around early to mid-November here, is my current favorite model. And what you can do is Anthropic, if you actually create an account and go to the dashboard here, you'll see we get a little generate prompt button. So if you actually click that, what you can do is you can just paste your basic prompt into here and then hit generate. What this is actually going to do is it's going to generate with Anthropic's prompting models, is actually going to generate you a much better prompt. So you can see what you could do here, and you'll see we get some of these values. So you have to edit this just a little bit, but we get a much better, more robust prompt that is probably going to be a lot better for our liking. So I have one that we're going to use here. Again, I'll have that below so that you can kind of copy and paste that right in. But I'm going to do that right now, and we'll kind of talk about it. So basically what I did here in this workflow was I pasted the basic prompt into that Anthropic tool. I got a result back, and then I sort of iterated on it myself just a little bit to clean it up, get rid of some of the things that didn't need. And you can see now we have a much more robust prompt here. What we'll do here is we'll actually set the prompt to use now to advanced prompt. And what we can do now is we can actually run this again. And what you'll notice is we get a slightly different answer because our prompt is slightly tweaked. So let's go ahead and let that run. And boom, here comes the answer. Okay, so it was a little bit more concise. Again, you're not going to notice huge differences in this particular example just because it's a pretty simple data set, right? But if you were doing things like maybe you have a company knowledge base or something, and you want to build a tool that your team members can ask the company knowledge base or something, right? You're gonna have a lot more need for an advanced prompt like this, right? So we could try like another query, right? Excuse me. So one of the things that we could do is like, let's do what do giraffes eat? What do giraffes eat? Let's try that one. Okay, so what we can do, we can run this again. This time we actually should get a name extracted, hopefully. So let's see how our RAG system did. Okay, it optimized the query. Honestly, not a great result there. That might be something that we want to flag. Make sure that we go update that. Again, our entity extractor is having a little bit of issues. That's probably something we want to go and grab, because this should be giving us giraffes, and for whatever reason, it's not. Again, we've kind of covered that a couple times, so I won't get too much into that there. But we got some retrieved results here, and then what you'll notice is we got that final re-ranking. And what I suspect is if we go into the mock data here, let's just do a quick search for giraffes. It looks like none of the 5 giraffe facts that we have actually have to do with anything food related. But what's cool is you actually can see that in the model's response, it actually, was able to inject those facts, and it was able to recognize like, hey, none of those facts actually had anything to do with your query. Okay, and it kind of addresses that here in the first sentence, and then gives you a little bit of an answer there, which is actually kind of the RAG system working, right? one of the things that you want to do, we talked about this in the previous intro section, is you want to reduce hallucinations, right? So if your RAG system isn't producing documents, it's not producing the context that's needed to answer the question, then it should actually answer like this. This is actually a good answer, right? So we go back to this and we look at like polar bears here. Okay, we can say, how long can polar bears swim, right? Let's maybe change our query to that, let's go ahead and give that a go. How far can polar bears swim? And let's run that and see if we get a good fact here, which we should be getting that. You can see our final re-ranking result actually was the polar bear swimming fact. You can see the relevance score is very, very high, right? 0.99. Again, this is the highest you can get is 1, right? So that's about as close as you can get. And you'll notice that our model with that advanced prompt gives us exactly the answer that we're looking for, right? One of the things that we could do is like maybe let's benchmark this and switch advanced prompt back to basic prompt. Let's run this one more time just for kicks and see if we get a worse answer with the basic prompt. My suspicion is it'll probably be pretty good. Again, the simplicity of the data that we're working with here isn't going to make the differences in prompting here seem too robust, but it's a good thing to be aware of because you do want to write more prompts. And if you use the Anthropic prompt enhancer here, just a nice little hack to write better retrieval prompts. And obviously you're going to want to tweak these to your use case, but the more clear your instructions are in those prompts, the better your model is going to be able to handle answering questions based on the context that you give it, right? So that is section 2. That is creating a full, complete end-to-end RAG system. You obviously learned how to take basic retrieval and drastically improve things. You can even see, as we've been talking about in the last couple, the last lesson or two, there's a few things here that we could even go in and make even better. I'll let you do that on your own time because we want to keep things moving here. But that is end-to-end RAG systems. I hope you feel like you've learned a ton. All of these concepts are very real world. As you up the complexity of your data set and you can move away from animal facts into longer data sources, more diverse data sources, things that are, business critical, things that are actually relevant to what you're doing in your everyday jobs and everyday lives. Maybe you have your personal journal, right? Maybe you have a whole, note somewhere that you want to create a RAG system for. Right now, you know how to do that. So we're going to go ahead and end this section here. In section 3, we are going to take everything that we've learned in sections 1 and 2, and we're going to actually apply our learnings to building a real world project. So let's talk a little bit about what we're going to be building here, why we're going to be building it, and some of the things that you're going to need before we actually get into writing code. So right off the top here, we're going to be writing a ton of code in this section. Okay, so this is going to be pretty technical here. If you do want to just cruise along and watch what I'm doing and then maybe go apply those techniques to your own project, that's great too. I do really recommend that you actually write the code with me because we are going to be building this cool little tool here. So your UI by the end of this will look a little bit different from mine because as we go about building this thing, we're going to be using a couple things like Cursor and V0 to teach some AI workflows as we kind of do things like building out the actual app UI on the front end side of things. But we're going to be kind of doing two things here. So one is we're going to be building a full retrieval pipeline, okay, very similar to what we did in section 2, complete kind of production grade end-to-end RAG pipeline. Okay, we want to do things like basic retrieval, query optimization, things like document re-ranking, all of that stuff. We're going to apply this to a document uploader that any text that we enter here is going to go get processed into our RAG pipeline, get uploaded to our vector database. And what we're going to be able to do in our AI chat over here on the right is we will be able to type a message here, ask any question we want about our uploaded documents. Okay, so whether you upload one document or you have 1,000 different things that you've entered here. The idea here is this is basically some sort of RAG pipeline over a knowledge base. Okay, and so you see this, this is a very typical workflow, very typical type of tool you'll see, right? You can imagine, if you had a bunch of company docs or something, maybe you're a financial analyst or something and you have a bunch of documents, you can put those all here, upload those, and then ask any question you want about your uploaded documents here. The retrieval pipeline is going to go ahead based on your query here, get the most relevant information that it needs, and then it's going to use an AI model. Okay, we're going to be using one of OpenAI's LLMs in this section to actually answer those questions, and then we're going to see our retrieval results. Okay, so we're actually going to be able to see the documents that the LLM is referencing in its context to give you an accurate answer to your question based on whatever documents you have uploaded. Okay, so this is a very common tool. You're going to see this pattern all over the place, right? If we take an example like Perplexity, for example, we've talked about that. I think in section 1 we talked about Perplexity a bit. Right, what they're doing is basically their document uploader is the internet, right? And then the idea is you go in to a UI, you ask a question, performs the whole retrieval process, adds the end of the context, and the answers it. Okay, so if you learn how to do this, you're going to have kind of the foundation that you need to build all sorts of RAG applications and tools of that nature. So this project ends up being pretty nice because you can kind of see all the RAG pipeline stuff that we did, very similar to section 2, but also seeing how that gets implemented into, an actual user interface, an actual app that you can use. Okay, so let's talk about what you will need to get started here. So obviously you're going to need to work in the code repository that we've been working in the other sections. So what you'll notice here, we'll have the GitHub link below. For some reason you haven't been following up to this point. But what you're going to want to do, and I'm actually going to stop my development server here, is you're going to want to make sure you run git pull origin main, or go grab the zip file of the code from GitHub, okay, because we have updated this section since you've taken section 2. Okay, so you're going to want to make sure that you get the updated code, and what you'll notice if you do that is you'll have this section 3 and you will have a reference app in here. So the reference code is going to have every single thing that you need to actually make sure that your code is right. Okay, so the project that I actually have running over here is fully represented by this reference code. So if you want to just take an example of kind of the final product there, any of those files, that code is going to be there, and we're going to be working in the same folder with a project right next to it that is for your code. Okay, so that's going to be the project code that we're writing in this section. So if you did take section 2, this is going to be very similar to how that was formatted, right? We had the your code and then we had the reference code. Okay, so you're going to want to make sure you pull the latest code, and then you will again need 3 things. These are the same 3 things that we've been using for section 1 and 2. Okay, so you are going to need one of those OpenAI keys here. So you're going to want to make sure you go to platform.openai.com, grab your API key, because you're going to need that. And then if you want to use document re-ranking, which I highly recommend you use, this is really good production grade practices here, and it's a good thing to learn. But you will also need a Cohere API key so that you can use their document re-ranking API. Okay, so that's important. And then of course, last but not least, is you're going to want to go to Supabase, and this we're going to go ahead and do the setup for this in just a sec here. But what you're going to need is a project there. Again, you can use a free Supabase account. You may need to delete one of your old projects if you've run out of free projects, which isn't a big deal, right? We're learning, so you can probably toss out the old thing, no problem. But let's actually just go into a quick little example here of actually using the app, so we can just give you a little bit of a preview of what we're actually going to be doing here. Okay, so one of the things that a RAG system like this could be really useful for, is blog posts, essays, things like that are maybe not directly included in the training data, or maybe you just want to ask really particular questions about it, right? If a model was trained 6 months ago, it's probably not, it's not going to have the new data, right? So for example, this is a Paul Graham essay that was written in October 2024, and this essay is not included in the GPT-4o that's not included in the training data. So if you were to ask a question about this essay, it's not going to be able to actually get an answer, right? It doesn't have anything to reference. So if I let me just run my local server here, npm run dev on the reference app, just to make sure that this is all up and running, and I'll kind of show you what's going on here. So one of the things that I could do is that I actually just embedded this essay. So let's do maybe the one previous. Okay, so this is an essay from September. It was 2024. So what I could do here is I could just literally copy and paste this entire thing. I'll even include that thanks to. We'll actually reference this. This could actually be kind of a cool example here. And so what I'll do here is I'll just paste this in. You can see we have all that text. And what I'm going to do is hit upload document. Okay, and what this is going to do is that uploaded all of my all of that text as a new data entry into this documents table here in my vector database. So you'll see here, this is actually the data for that. So what we can do here is if we take a look at this essay, let's go and try and maybe find something we could ask a question about. Let's say, what do we get in the face of uncertainty, right? Let's try and let's actually ask that question here. Actually, you know what? Because we're going to be copying that exact query, that might be like the embedding for this is going to be basically the same. So let's actually do let's do something like should I wait until the end of college to figure out what I'm going to work on? And let's just see what it says. Okay, so we're going to send that off here. What we're going to get is we're going to get our query here in green. And what you can see here is if we scroll down, let's actually hide our sources for a sec. So it says, no, you shouldn't wait until the end of college to figure out what to work on. And you can see it kind of is pulling from these three sources here. So you can see these were the three top ranked documents that came back at the very end of our retrieval process. So you can see that snippet of the essay is kind of getting chunked in here. So we're going to be doing kind of a simple chunking technique here. There are much more, really advanced methods of doing this, which I'll kind of at the very end of this give you kind of as a bonus challenge and show you where you can kind of start with that. In the future, we may do some videos if there's demand for it on some of those, little individual lessons on specific document loaders, but this kind of covers the gist of it. And if you get this down, it's pretty easy to move on to those other ones. But that being said, let's actually just go ahead and move on to getting the code set up so we can actually build this thing from scratch. Let's go ahead and move on to initializing our code. So this is going to be fairly simple. I'm going to really quickly just navigate back to the parent directory here so I can navigate with you as if you were kind of following along with me here. Okay, so what you're going to want to do is you're going to want to make sure that you go back to cursor, back to the code repository. And what we're going to do, okay, is you can see I have my terminal open here. We're going to navigate to where we're actually going to be building the project in our repo here. So we're going to change directory into sections, and then into section 3, okay? And this is where we're going to run our initial setup script. Okay, so this is going to sit right next to that reference app project K, and we're going to create a new app here. And what we're going to do here is we're going to use the shad cn CLI, which is a really awesome way to get your project set up. This is the same way that we get our Next.js full stack apps set up all across Takeoff. So you may probably be familiar with this. You may need to actually go and actually run some sort of install command. Your terminal here might actually tell you that you have a command to run, and then you have to run this again. But what we're going to do here, we're going to run npx shad cn at latest space init. Okay, and this is going to initialize a new project here. It looks like, did I spell something wrong? I did. I did shad n. It's shad cn. Let's run that again. Okay. And so what it's going to do is going to recognize that we don't currently have a Next.js project here. So you can see the Y is capitalized. So I'm just going to enter, and I'm just going to name this, you know what, let's just kind of do, we'll name it like my rag app. How about my rag app? Okay, so what this is going to do is it's going to set up a new Next.js project in this folder here. Okay, as you can see, now we have reference app here, which is the completed code, and then we have where we're going to be working from now on, which is this my rag app folder here. Okay, so what you have to do here is you have to run a little bit of a setup steps here. So we're going to go set up default as our style. We're going to use the neutral color as our base. Want to hit yes here. Okay, and this is going to install kind of our basic dependencies and get us running with a nice little simple app here. And so what we can do once the project initialization completes is we're going to change the directory into that rag app folder here. Okay, and if you run npm run dev what you should be able to see is you should see your app running at localhost 3000. So if I go ahead and give this a little bit of a refresh here, we now have our starter app. Okay, so this is a starter Next.js app initialized with the ShadCN CLI so that we can get a bunch of extra bells and whistles out of the box here. Really nice little setup step if you're not familiar with that one. But what we have to do here next is we're actually going to add a few ShadCN components. So if I actually pull, let me pull in the ShadCN docs here. So I'll make sure I link to these docs here. This is going to be something that you'll probably want to get familiar with, especially if you're building out a lot of your own full stack projects. So what we're actually doing is we're just following this Next.js guide here. You can see that this is really familiar here. Okay, and one of the things that we're going to be doing here is we're going to be taking advantage of this component library. Okay, so for example, if I click on this button component here, one of the cool things here is we can actually just install this button component and we get this really nice looking button right out of the box. So we're going to do that with 3 different components here. We're going to go back over to cursor here, and you can see you should now have a terminal running your local host app, which is great. I'm going to create a split terminal here. You might just want to create a new one. I kind of like the split version here, kind of have my app running over here, run some scripts over here. And what we're going to do now is we're going to do npx shad cn at latest, and we're going to do add, and we're going to add a button, input, and text area. Okay, so we want these 3 components. If I hit enter here, what you'll see is we actually get a new folder over here in our file explorer, and we get the button component, we get the input component, and we get the text area component. Okay, so now we don't have to build those components ourselves. We get those right out of the box. ShadCN has all of these different components that you can use. Highly recommend it. One of the most popular libraries in the entire world right now. It's kind of the hot UI library, and it's going to make your life a lot easier, so get used to using that. Once you have those components installed, we're going to install a few software libraries that we're going to be using in our project. Okay, so these are going to be pretty familiar. So we're going to, I'm actually just going to copy and paste this because it's quite a few here. I'll have the script for this below so you can just copy and paste that as well. But we're going to be running an npm install on these handful of libraries. Okay, so this is going to be like the OpenAI SDK. We want to use Cohere's SDK. We're going to use the Vercel AI SDK to do things like actually implementing that AI chat feature. We're going to be using tick token to count. In section 2, we split our documents by, I believe we did word count. We're actually going to be doing token count this time, so we're going to be going up a level there. So we need all those different things, and then you also need to run the following script for your developer dependencies. Okay, so these are just going to be some of the things that we need on the developer tooling side of things to get things like our migration scripts written with Drizzle. Okay, so that is some of our code setup there. One of the things that we should do here is we actually need to set up our environment variables. So if I go over to the reference app really quickly, what you'll see here is you'll see this .env.example file. And if you've been following the rest of the course in sections 1 and 2, it's going to look really familiar. So what you want to do here is you actually want to go back to my rag app. You want to create a new file called .env.local. Okay, so .env.local, and then we're going to go grab that example file. We're just going to copy and paste these values over into the .env.local file here. Okay, and so I'm going to do this off screen here so that I don't expose my API keys. But what you're going to want to do is enter whatever your OpenAI key is. You're going to want to enter it there, whatever your Cohere API key is there, and then we're going to go ahead and get started with our database setup step in the next lesson. So get up to this point, get that OpenAI key there, get the Cohere API key there, make sure that your app is running on localhost, make sure you get those 3 components installed so that you have those to work with, and then let's move on to the next lesson. Now that we have the very base code of our app scaffolded out, thanks to that ShadCN initialization step, what we can do is we can actually get our vector database set up. So this is going to be very similar, actually identical to what we did in section 2. So at this point, getting a vector database set up in the way that we've been teaching you to do it here with Postgres and pgvector, this should feel pretty standard. At this point, this is something that, anytime you set up a retrieval project, you're going to need to do something like this. Even if you go about using, a different vector database like Pinecone or something, the same kind of steps are going to apply. You're going to need to go set up that database. You're going to go, need to figure out the schema for whatever table you want to use for retrieval, and you got to go get that set up. So we're going to do it the way that we do it here on Takeoff, with Postgres and PG Vector. So let's go ahead and jump right into that. So you'll see here I am on supabase.com and I am on the create new project screen here. So what we're going to do here is we're going to just create, we're going to call this, I'm just going to call this Takeoff rag live, just because I'm kind of doing this live. And what we'll do here is we will generate a password. You can of course pick your own. I'm just going to use a generated one here. Reminder, you need to keep this secret. So this is, treat that value like a password. Obviously, it says database password, so make sure you keep that private. I'm obviously only showing you these so that I can teach things. So what I'm going to do is I'm just going to copy and paste that value into that .env.local file. I know this isn't in the right place right now. It's because we have to change that database URL, which you're probably familiar with if you saw section 2. But we're going to go ahead and boot this project up. This typically takes a minute or two to initialize that database, so I'm going to cut to when this finishes. Boom, our project is set up. Let's go ahead and grab our database URL here to actually connect to this thing. So you're going to go ahead, go over to the sidebar here into project settings, and then in project settings you want to go to the database page here. This is where you are going to find the connection string for your Postgres database. Okay, so go ahead, copy that guy, and bounce back over to your code. You're going to paste that into the value for your database URL. Okay, and once you have that value in there, now we're going to go ahead and cut the value that we saved here, and we're going to replace this bracket, your password value. Boom, we now have our connection string that we need for our app. Okay, so before I close this file, just want to remind you a couple things, because environment variables are very important to get right. Okay, you need to have this in .env.local. You need to change whatever, I just have a test value here. I'm going to go ahead and do this right after I stop this, but I'm going to put my key in here for OpenAI. Okay, I'm going to put my key here for the Cohere API, and then I'm going to, obviously I already have my value here, which is fine. And don't share any of those values with people. Treat these like passwords, because if people get access to these values, they can access, your account credits and get into your database and things like that. So make sure that these things are secure here. So I am going to go ahead and get my values, put those there, and close this file and be right back. Close my file after putting my keys in. And what we need to do now is we actually have to get our drizzle files. Okay, so we did all these steps in section 2, but we're going to do them again for this project. Again, the reps are helpful. You need to get used to doing kind of these things. Again, you can use your own technology stack here. If you want to use a different vector database, that's totally fine. There's plenty of options out there. This is the method I use. I find it to be really reliable. It tends to be a pretty convenient technology to work with. One of the advantages of using the stack that we use in Takeoff is that the AI models have really good context into it too. So if you're using tools like Cursor and V0, ChatGPT, Claude, any of these things, they're going to be able to give you really good answers because the libraries are kind of in the training data a bit. Okay, so that's one of the big parts of why we use the tech stack that we do, if you were kind of curious on the decision there. But what we're going to do here, okay, got to make sure, again, you got to make sure you're doing the code here in my rag app and not the reference app. The reference app is the completed code. Again, at any point in time, if you want to reference any of the files that we're going to be working on, you can go into the reference app, right? So for example, one of the things that we're going to be doing is we're going to be working with our drizzle config here. Okay, and what I'm actually going to do, because these are pretty boilerplatey setup steps, is I'm going to kind of take advantage of this, and we're just going to do some copy and pasting here, okay? So in my rag app here, the first thing that we're going to do is create a drizzle.config.ts file. Ours is going to be empty, and literally what you want to do is you want to just copy the one from the reference app and paste this right in here, okay? There's no sense going in and writing all this from scratch. This is just boilerplate stuff that we need to get our database set up, okay? So we're going to kind of speed up those mundane boilerplate steps a little bit. Next thing that we need to do is we need to create a new folder in the My Rag app folder here, okay? And that's going to be called DB. And what we need to do in DB is we're going to create a new file called db.ts here. Actually, I think the reference, sometimes I do db.ts, sometimes I do index. So we'll go ahead and keep this consistent with the reference app here, but we're going to go ahead and grab the code from the reference app here. Again, this is just very boilerplate stuff that if you're setting up a project for the first time, you can just kind of copy and paste this. And then what we're going to be doing here, okay, is we're going to create a new folder inside of the DB folder called schema. And we're going to create a new file here called documents-schema.ts. And what you'll see here is if we go, I actually, for some reason, called this documents data. We're going to stick with document schema. That's a better naming convention there, but we're literally just going to copy and paste this table here, and we're going to paste it into ours. Okay, so at this point, you should have added the drizzle.config file, which is at the top level of your project. And then inside the DB folder here, we have the index.ts file here. You are actually going to need to tweak that naming there. I may update this in the repo so that that's consistent. But if you run into that little error there, just make sure you get that file name changed for the import. Otherwise, you're going to run into some errors there. And then we're going to have our documents table here that is defined in our schema file, okay? So again, we're kind of going over this a little bit quickly because in section 2, we did the exact same thing and we kind of did it line by line and explained what was going on. But we're just going to kind of speed through that. Again, I'll talk for just a second here about the table because I do think that matters a little bit. Okay, so we have an ID column, right? These are all just column types. We're going to have an ID column. We're going to have our content column. Okay, so this is where our text is actually going to be from, in our app where we have that big text area and we upload our text, right? That's what the text is. We're going to need to use the vector column. Okay, again, that's what we get from PG Vector. We covered all of that in section 2, so we'll kind of go over this a little bit faster here. But we're going to be using 256 dimensions again with our embeddings just because we want to keep things fast, keep things nimble, keep things cheap. If you are doing a production database, again, I do recommend you bump those dimensions up. We have links to OpenAI's embedding documentation. So if you want to kind of learn maybe what a good dimension count might be for your use case, if you're trying to get better retrieval results, and you're comfortable kind of with some of the larger requirements that you're going to need on the server end for actually running your database, go ahead and give that a peek. But we're going to keep things pretty simple here. And then, of course, we need our embedding index. I'm actually going to change this from data to documents here. Okay, so this is going to be documents. And what we'll do here is we actually need to generate the SQL migration file from this drizzle file here. Okay, so we're basically writing all of our database schema here in TypeScript. It's going to keep our database type safe across our app, which was going to be really helpful for us to, especially as we're building full stack apps. When you're doing things like kind of more just back end tools like we did in section 2, it's not as obvious why this is nice, but it becomes much more obvious when we work with things like front end. And we need sort of this insert and select document type all over the place. So what we can do here is we actually need to make a slight tweak to our package.json file here. So what we actually need to do is we need to create 2 scripts. Okay, we need to do db::generate. And this is going to run drizzle kit generate. Actually, what we can actually do is we'll just reference our reference app again, because what we want to do here is we want to just copy these 2 scripts, okay, the generate script and the migrate script. This is going to be consistent across all the apps you do. So again, this is just a very boilerplate step here that we're kind of taking care of here. And once we have that, we can pop back into our terminal here. Okay, so again, I have my terminal that's actually running the app with npm run dev. Again, you can just run this npm run dev. That's going to run this dev script and actually spin up your app. Okay, and then you can access that on localhost 3000. Then on the right here, okay, I have my other terminal here. We can actually run some scripts. So I'm going to do npm run db generate. That's going to run this script right here. So we'll go ahead and hit enter. And you'll see we now have a new folder here. You'll see we have inside of our database folder, we now have a migrations folder with some stuff. The primary thing that we got in here being our SQL migration file, which again, this is what you're going to need to actually run against your Supabase project to get that table created. And just a reminder, like we did in section 2, we actually have to create create extension if not exists vector. Okay, so this is the this is how we add the PG vector extension to our Postgres database so that we can actually take advantage of that vector embedding type, right? This is what enables that entire basic kind of cosine similarity search step that we're going to be doing for basic retrieval. So you're going to want to make sure you get that line added to the SQL file that was generated. And then if you run npm run db:/migrate, what this is going to do is this is actually going to apply your migrations to your database. So if we go back over to our Supabase project here and I go to my table editor, what you should see is you should also see this documents table. Okay, so on the left sidebar, table editor, you'll see this new table documents, and you can see it has all of those column types that we defined in our schema file. Okay, so if for some reason you run into an error with that step, it's likely that in your .env.local file, you may have entered your database URL incorrectly. Maybe you didn't replace the password, things like that. So if you run into errors there, typically 99% of the time, that's what it is. But that being said, that is everything that we need now to actually start building our RAG pipeline. Okay, we have our vector database set up here in Supabase. Again, we're just using a pretty standard Postgres with PG vector setup. This is what I use for all of my projects, both kind of personal projects and tools and experiments, and also production grade things. So I have a variety of production grade apps, with like actual real world users that's using the same setup. This is a very standard thing. Again, we've kind of covered some of the details there, so we're gonna keep things rolling here and actually just focus mostly on building. But you should make sure that you get to this step, and then we're going to move on to the next lesson, which is actually building out that RAG pipeline. What we do in this section is going to be very similar to what we did in the entirety of section 2. Okay, so we're going to actually be building our RAG pipeline. And one of the great things about building a RAG pipeline once you've set it up once, it's very quick to set it up again, right? Because you can copy and paste code that you've used before. You can kind of tweak some of those things to kind of fit your use case a little bit more. But the nice thing is every single RAG pipeline is going to mostly, for most of your project can have kind of that same foundation that you can reuse over and over again. So let's jump into our project and we're going to look at what I mean here. Okay, so we're going to be referencing a lot of the code that we wrote in Create a RAG System. If for some reason you didn't follow along with section 2, that's totally fine. We're going to be talking about it just a little bit quicker here in this section. And because we have all of the reference code here, you're still going to be able to follow along just fine. Okay. So one of the things that we want to do, okay, is we want to go into this lib file, this library file in my RAG app here, and we're going to create a folder called RAG. Okay, so this is where kind of all of these utility functions are going to live while we kind of build the system out. And we're going to organize this into 3 parts. We're going to have a generate folder here. Okay, so some of our generation functions like our embedding generations and our context completion. Okay, so that final API call to the OpenAI API that's actually going to get us the final answer case. We want both of those. We're going to want a retrieval folder here. Okay, so this is where we're going to have some of the more retrieval oriented functions like our query optimization, things like that. And lastly, we're going to have a processing folder here. Okay, so this is where we're going to have some of our, our chunking, our text splitters. Okay, so this is where we're actually going to use that tick token library that we installed to actually tokenize the text that we upload so that we can actually kind of chunk those into 500 token chunks so that for really long data entries or whatever, it actually doesn't get you're not having like a 15,000 text file get embedded, right? You want to break that up, which again we covered a lot of these techniques in section 2, and we're just going to kind of string all of those together here, talk a little bit about them so that we can build a full end-to-end RAG pipeline that we can use with the UI that we're going to build in the next lesson. So let's go ahead and get started with those completion generations. So what we're actually going to do, like I said, is we're going to create the files first. So let's actually go ahead and create a generate-completion.ts file. We're going to want, and this shouldn't be in processing, so I'm just going to drag this up to generate. Okay, we're going to have a generate embeddings.ts file. Okay, so those, let me make this a little bit bigger here so you can see those full file paths. Okay, so in your generate folder, you should have a generate completion and a generate embeddings file. So let's go ahead and let's just start with the embeddings. So If we actually go to the reference code from section 2, which you'll have in this repository here, is this first file here, this generate embeddings. What we're going to do here is we're actually going to copy just the function here. So we just want to copy the function. If you want to keep the comments just for a little bit of commentary as you kind of review the code, that's totally fine too. So we'll go ahead and do that, and we'll jump back into our new file here, and we're going to paste that in. And what we'll do here is we're actually going to mark this at the very top of the file with what's called a directive. This is going to be used the use server directive. So this is just going to let our app know that we want to run this code server side, not client side. So client side is on the browser, server side is on the server. And you can see cursor tab is actually accurately predicting just what we need here. So I'm just going to hit tab here. What this is doing is this is just importing the OpenAI SDK, and then we're just getting this set up. And what actually happens in the background here is that OpenAI uses the environment variable that we have in our .env.local file. What's nice is it just automatically pulls that, assuming that you name that value OpenAI API key equals whatever your key was, which is exactly how we set up our project. Okay, so you're going to be all set. You don't actually need to do the API key in there. And what you'll see here is we're actually going to use the exact same function that we're using in section 2. Okay, so we're going to still be using the small model here. Again, that's just to keep things cheap. Again, our dimensions here need to match with whatever we did in our schema file. So we refer back to the schema file. Okay, 256 here, 256 in the embedding function there. Boom, we're all set. And the way that we're going to actually call this function when we're working in our code here, so we're just going to provide that array of text strings here and pass that into the API. And what OpenAI does is they use their text embedding 3 small model on our text to encode that data in 256 floating point dimensions to grab that vector embedding, and then we just return those values. Okay, so that's pretty straightforward here. The generate completion folder or file here is going to be pretty simple here. So if you actually go into the 9-rag prompting, this is actually going to be pretty similar to what we're going to use here. So what we're going to do here, okay, again, I'm just going to grab that code right there, and I'm going to go up to right here, and we're going to copy basically this async main function here. And we're actually going to need to tweak quite a bit more than we needed to tweak with the embeddings function. So let's go ahead and do that. The first thing that we're going to need to do is, you can see cursor tab is, again, we're going to accurately use tab completion there. Okay, so we need that use server directive, we need to import OpenAI, and we need to initialize the client. Once more, we're just going to initialize the client in every file here, just to keep things pretty simple. And what we want to do here is we want to export this. Export, if I could if I could spell export async function, and we're going to name this generate completion with context. And this is going to take in 2 parameters. It's going to take context, which is a string. It's going to take the input, okay, so whatever the user input is as a string. And then it's going to be all the code here. You can actually get rid of it all the way to this completions code here. Okay, so you can get rid of it all the way up to there. And what we can do here is we're going to change a few things here. We're going to actually change, we'll keep model at GPT-4o mini. Again, you can use whatever model you want. We're going to use mini just because it's the cheapest here, which is always nice for testing. We're going to set temperature to 0 so that our answers are a little bit more deterministic. We're going to set max tokens to 1,000. So the maximum tokens that the model can output is just 1,000 tokens. We'll change the system prompt here just a little bit. We're going to make, again, if you want to build a more advanced tool, this is like a great stretch goal. Go ahead and make this prompt more complex, tailor it to a specific use case. Feel free to go wild here. We're going to keep this pretty simple, which is we're just going to say answer based on the provided context here. And then we're going to do a new line here and then go context colon. And then on the next line, we'll actually put that context. Okay, so we'll have a system prompt that meets that criteria. And then for the user message here, we're just going to use that input value here. And we're actually not going to stream this. What we're going to do here is we're just going to return the completion. Okay, and you need to return completion.choices, get the first value off of there, and then you need to get the message.content off of that value. And then we also need to get rid of stream true right there to get rid of that little error here. So what this is going to do is we're going to be able to call this function with whatever context that we get. Okay, and again, the context that we get is going to be the end result of our retrieval pipeline. Okay, so that's what's going to get passed there. Plus our user query, it's going to hit the OpenAI completions API. It's going to hit GPT-4o Mini, and it's going to build those messages, and then we're going to get a response back, and we're going to get whatever the text is of that message. Okay, so that's what those generate functions do. So that's kind of step one here. Step two is we actually need to do a couple processing functions here. So we're actually going to be doing two things. The first function that we're going to need is we're going to want a split text function here. Okay, so let's go back over to our folder here. And we're going to do split text.ts. And we also want a process-document file here. Okay, so again, two more files here in the processing folder here. Okay, so this is going to, if we jump back into the split text file here, what we're going to do here, okay, we're going to mark this with use server again. We want this to run server side. This is a requirement of how tick token works. What we're going to do is we're going to import this helper function here called get encoding from tick token, and we're going to use that in our text splitter function. So let's go ahead and just initialize a function called split text that takes in one argument that is a string called text here. And what we're going to be doing in this function is, instead of in section 2 where we split the text based on word count, we're actually going to be splitting based on token count, which is kind of cool. So what we're going to be doing in this particular example is we're going to be splitting all chunks into 500 token chunks. There are a lot of different ways that people split their documents. So we'll talk about this probably more towards the end. But one of the things that I would love to teach you here is just how to split on tokens, because that's one of the most popular splitting techniques you'll see in kind of production grade RAG systems. So what we'll do here is we're going to create an array called chunks that is an array of strings, and we're just going to set that to an empty array here. Next thing we're going to do is we're going to define a chunk size here. Okay, so I recommend doing somewhere between 500 and 1,000. Those are probably the two most common values you're going to see if you're setting a specific limit. Again, a lot of people will chunk things differently that are like semantically or based on headings or new lines, things like that. But just to keep things simple, we're just going to do 500 token chunks. What you need to do is you need to initialize this encoding variable. Okay, and this is going to define what encoder we're going to be using, which in this case, we're going to be using CL100K base. This is just a tokenizer that you can use that is relevant to OpenAI's models here. Okay, and what we're going to be doing here is we actually are going to want to wrap our code in a try catch here, because what we're going to want to do is we're going to run some code, and then at the end of it we're going to do this finally here. Okay, and what we need to do at the end of here is we need to run encoding.free, which basically ends the encoding sequence. And what we'll do here is we'll create a variable inside of this try block called tokens. We're going to grab encoding, and encoding has this helper function called encode, and we are going to encode our text. Okay, so this is going to take whatever text we give this function, it is basically going to tokenize it. And what we can do here is we can basically count. Okay, so we're going to create a for loop here. Okay, so I have a very basic for loop that's just literally iterating over each token. Okay, and what we're going to do here is we're going to call a variable called chunk tokens, and what we're going to do is we're going to call slice on tokens. So this is basically just slice here, slice. What this is going to do is this is going to slice the it's going to slice that encoded value here every 500 chunks. And what we're going to do here is basically every 500 chunks we are going to push a new chunk into the chunks array. Okay, so that's all this is doing. It's looping over our encoded value. It's figuring out, okay, do I have 500 tokens in here? If I don't, keep going. Otherwise, we want to push that value here. Okay, so we're going to go chunks.push, and then we don't need this return value here. And you can see we're going to be, it looks like I'm getting an error here. I called this chunk. This needs to be chunks, okay? So we're going to be looping over that every 500 tokens. We're going to be pushing a new chunk, okay? And so what this is going to do is going to take that text and it's going to get it into 500 token chunks instead of just one big giant one, okay? And that's very, very important to learn as you work with RAG systems, right? Because, say you have 100,000 token PDF, right? You're going to need it. You're going to need to split that sucker up into a bunch of different chunks, okay? So chunking, splitting text, covered it in section 2, but we're just changing things from words to tokens. So that's I know there's a lot of like technical stuff going on here, but hopefully you can kind of get it. Again, if you are working in something like Cursor, go ahead and ask a few questions if you're lost there. But we're gonna kind of keep things moving here. So for the process document function, the idea here is we want to build a function here that is going to take our text that we enter into our UI. It's going to split that up with the text splitter function that we just wrote. It's going to embed all of those different chunks, and then it's going to upload it into our database. Okay, so we're going to go ahead again. We're going to use server. We want this to run server side here. And we're going to do async function here. Process document. Once again, this is going to take a single parameter called text. Pretty standard stuff here. And what we need to do is we need to do those 3 steps. Okay, so let's start with chunking. Okay, so the first thing we need to do is create a variable called chunks. And what we're going to do is we're going to go await. We're going to grab that split text function here. Okay, so we're going to import this function that we just wrote here. We're going to finally use it. Okay, and we're going to pass in our text. So what this is going to do is this is going to split this string into chunks of 500 tokens a piece. Except for the ending one, of course, because you're not going to have exactly 500 at the end there. What you need to do next is you actually need to embed those chunks, okay? And to grab those embeddings, we can create an embeddings variable. And now we can finally put our embeddings, generate embeddings function to use, and we can just pass in the chunks that we got back from split text, okay? So you can see how these things are starting to work together a little bit, which is kind of nice. Looks like I may have done a type error here. Really quick, let me figure out what this error is. I'll be right back. Okay, so the error that I accidentally made was I needed to keep that return chunks here. I accidentally got rid of that, so make sure you go back to your split text file here, and at the bottom of that try block, you want to return the chunks. Then if you go back to process documents, you'll see the squiggly line there is gone if you're using ESLint, which I think the setup for this automatically does that for everybody. But so let's actually move on to the third step here, which is actually getting this inserted into our database. Okay, so we're going to use db.insert. Okay, we want to insert onto that documents table that we built. And the values that we're going to use here is we're going to map over these chunks. So we actually want to grab the chunks and their index. Okay, so that's what this I stands for, index. And then for each one of these records, what's going to happen is content is going to be equal to whatever that chunk value is, and then the embedding is going to be the embeddings at that particular index of the chunk. Okay, so that's pretty straightforward here. Okay, so we're going to get the imports for these right. We're going to import document table here. Okay, so again, DB is going to come from your DB setup that we did earlier. And at this point now you have a process document function. So this is a little bit of a long lesson here because we're doing so many different things here. The last and final thing that we're going to do is we're going to build out the helper functions here that we need for our retrieval folder. So we're going to need three or four. We're going to do 4. We're going to do 4 files here. We're going to need optimized query.ts. Again, these are going to look very similar to what we did in section 2 because as I mentioned, okay, we need to retrieve documents.ts, rerank documents.ts, and run rag pipeline.ts. So as I mentioned at the top of this lesson, we're going to be using a ton of the same things that we did in Retrieval. And once you set up a RAG system once, you can reuse a lot of those. So that's kind of what we're going to be doing here. Okay, so let's actually start with optimized query here. We're going to jump back into section 2 into the reference code, and you can see file 4 here. We're actually going to basically copy this same thing here. So I'm going to actually we'll copy it with the comments, give you guys some comments there. We're going to paste this in here. Again, you will we're actually going to run import OpenAI from AI. We're actually going to put use server at the top of this as well. We want this one to run server side here. Okay, and again, this is going to do our query optimization. I won't cover this detail here because we did that in section 2 here. But the idea here is we're taking our input, our user input, we're trying to optimize that input to some sort of a query that we can embed to get better retrieval results. So again, we covered the why and the how behind that. So we'll just kind of keep things moving again. We want to just focus on implementation here. One thing I am going to add that we didn't add in section 2 is the following here, which is I'm going to put just a few examples in here because as I mentioned in section 2, one of the things that we saw was the outputs that we were getting from the model weren't always the best. So one of the things that you can do in a production setting, okay, when you're trying to get the RAG system to be really good, is you can actually do what's called few-shot prompting here, which is basically we're just giving the model a handful of examples here. So in this case, we're doing 6 examples where you can see some like really basic user inputs here, and then an arrow with the result of what we'd want that to be. Okay, and so you can see how we're taking, show me the latest news about the iPhone. And we're just narrowing that down. We're optimizing the query with a really cheap model like GPT-4o Mini to kind of get a better result that we can actually pass to an embedding model. It just makes the kind of retrieval step a little bit more accurate there if you do that. Okay, so that is optimized query. Let's go ahead and do the retrieve document function next. Okay, so we're going to do retrieve documents. And what we want to do here, we're going to do something that's pretty similar to what we did in the section 2 with our retrieval function, but we're actually going to simplify it just a bit because we're actually not going to do metadata filtering this time, just to take away one step that isn't really applicable for our use case here. If you wanted to do that as a stretch goal, that's something you could certainly do, but we are going to reuse the input parameter and the min similarity parameter here. So if we actually jump back over to, let's see, where do we actually do this? The retrieve data function from section 2 in the reference code folder here. This is going to be the third file here. We actually are going to grab everything from this const similarity thing here all the way down to return documents here. We're going to go back over to our file and paste this into the function here. Need to make a few tweaks here. Okay, so we're going to get rid of name. Like I said, we're not doing metadata filtering. We're going to need to adjust our where clause. Okay, so we were doing a conditional where clause. We can actually just get rid of everything before this last similarity check here. Okay, and then of course we're going to need to do a quick change here to change facts table to documents table. We're obviously using a different documents table. We're not using the name value again, so we can get rid of that one. And your file at that point should look like this. Okay, so this is what your function should look like. At a high level here, what's going on is we're passing in our user input. Okay, we're passing in some optional parameters, which is a document limit that is defaulted to 10 and a optional minimum similarity score, which is defaulted to 0.3. Again, you can tweak these values to your liking depending on your use case, depending on how you like your system set up, but we're going to keep those values the same as we did in section 2 for some consistency here. And then what we're doing is we're computing the embeddings for the input. Okay, so in our case, this is going to be whatever the optimized query is going to be. Okay, so that's going to get optimized. It's going to get passed into this function. We're going to generate an embedding for that, and then we're going to generate similarity scores that compare the embedded optimized query against all of the contents embedding that we have in our vector database, and then we're going to retrieve the 10, in this case, using the 10 default here, 10 most similar documents, and then we're going to return those. Okay, so again, we went over that in the previous section. So we'll just kind of move on to the next step, which is the third step in our full RAG pipeline. Okay, so it's going to go optimize query, then retrieve documents, and then re-rank documents. So in this case, we can jump right back up to our reference code from section 2. We're just going to grab the file 5 here, re-rank documents. We're just going to grab the rank documents function, that entire function here. Okay, so this code to this, we're going to go back into our file here. We're going to paste that in here. We need to do a couple things. Okay, so this is going to be another use server function. Okay, so we're going to run the cohere API on, okay, and this is actually importing Cohere incorrectly. Okay, we finally got a hallucination from cursor. This is actually the Cohere client from Cohere AI. Okay, and then of course we need to initialize things, and for whatever reason, you actually do have to put the token in here when you're initializing the Cohere client with the environment variable. I don't know if that's a bug with how I've set things up, but just be aware that for OpenAI, for whatever reason, you don't need to do that. For Cohere, you do. So just make sure that you add that here. And then this is going to be pretty much identical to what we're going to be, or what we were using previously for the lone exception of we're actually going to get rid of that name parameter here. Okay, so we actually can get rid of name down there and up here, because then we're just using content. In section 2, we use name and content. In section 3, we're just using the content field. So this is going to run the documents that we get back from our retrieve documents function, and that is going to run the Cohere Reranking API to further optimize our retrieval results from most similar to least similar. Okay, and then finally, I know this is getting really long-winded, guys. We're almost at the end of this thing. Again, some of you hopefully are kind of speeding through this a little bit because we did this same exact thing in section 2, but obviously we need to repeat that so we make sure everybody's kind of hanging with us here. And then in the run rag pipeline function here, again, this is going to be server function. Use server, and we're going to do export async function run rag pipeline, and this is just going to take in whatever that user query is. They're going to take that single user query and it's going to run our entire RAG pipeline. Okay, so the first thing that we need here, optimized query. Okay, and we're finally going to take advantage of that get optimized query function. And of course, we pass in the query as the single argument to that function. And let's actually log that out so that we can, as we're running our app, we can kind of see those results in real time. Then we need to go grab step 2, which is the basic similarity search that we're going to be running on our vector database. We're going to be passing in 2 parameters. We're going to be passing in that optimized query. And then we're going to do a limit. We're actually going to do a limit of 25. So we're going to actually override that 10 default here for this example. We're going to grab 25. And what we can even do actually is let's do min similarity. And let's get a little bit more generous. Let's use a 0.2 so they could be a little bit less similar since we're getting a bunch more records here. And let's go ahead and log both of the 2 things here. We're going to log out those documents and then just the length of them so that we can see how many we actually get back. Remember, just because we defined 25 here doesn't mean we necessarily are going to get 25 back. We may not have 25 records in our table at the time of running that. 25 of them may not necessarily meet the criteria that we've set, that minimum similarity score. Okay, so we actually may get less. So we'll see. And then lastly, we need to run those results. Okay, those documents, we're going to call this ranked results. And we actually need to run all of those documents with that optimized query through the re-ranker. Okay, and what we're going to do here is we're going to grab the 5. We're going to override that and run this with 5. Okay, we're going to log those final results. And then, of course, we want to return the ranked results. Okay, so we just went through all of these. Okay, we actually did what? 4? We did 8 different files here. So quite a bit of work here. But that's an entire RAG pipeline. It's going to take the user query. It's going to optimize it. It's going to run that through a basic similarity search with cosine similarity in your vector database. It's going to retrieve those documents, okay, based on these parameters that we've set. And then it's going to run those documents into a re-ranker. Okay, again, we're using Cohere's re-rank API for that. And then at the very end of that, we will have those ranked results. We will have the ranked records from our database. Hopefully it is those 5 most similar, assuming that we got a full fetch result there. What we can do is we can feed those results into that completions function here to actually get an answer. Okay, so again, I know that was a lot. You may want to refer back to section 2 for quite a few things if you want a little bit more in-depth discussion, a little bit more in-depth explanation on some of the steps. But that's our RAG pipeline. That's what we're going to be using in this next lesson. So let's go ahead and actually get building the UI for that. This is typically where everybody has the most fun. Okay, so we're finally going to connect a RAG pipeline. Okay, we're going to connect this thing you built to an actual working front end. So the idea here is we need those two basic parts that I mentioned at the very start of the section. Okay, we're going to need the document uploader on the left, and then we're going to use the AI chat on the right side of things. Okay, so we kind of need those two different things. So what we're going to do here is we're going to go into our project here. So in my RAG app, and in this app folder, this is kind of where your client-side app code is going to live. So if you actually open up layout here, open up page, we're going to be working in these two files, and we are going to need two custom components that we make ourselves. Okay, so in our components folder, you need to make two files. You need to do AI chat.tsx, and you also need to make a document uploader.tsx. Okay, so we need to make those two components so that we can import those into our page and actually have some semblance of an app to actually work with. So we're going to do two things here. We're going to split this up into kind of two parts. So I'm going to show you a really nice way using AI tools how to prototype UIs for this kind of situation here. This is a very valuable tool called V0 that you can use. Very well done. This is by Vercel. Okay, so like we use their AI SDK. If you've taken our app course, this is what we use for deployments, things like that. And what Vercel is, they have kind of this ChatGPT type app that's specifically for development questions. So one of the really nice things, if you're familiar with something like Claude Artifact or GPT, I believe they call their version of that like Canvas or something. What we can do here is we can say, hey, I need a text area to upload a document. I need to copy and paste some text into that giant text area, and I need to be able to hit an upload button. Okay, and what we could do is we could send this off here, and what V0 is going to do is, and I believe you should be able to trial this for free. I believe they have a message limit. So this is one of the pro tools that I actually do pay for. I get a ton of value out of this. You can see on the right here, we're kind of getting a component that we can use in real time in our project. And what's cool about it is not only does it generate the UI, but if we were to say, awesome, put it on the left side of the screen. On the right, we need a basic AI chat interface. What you'll see here, then V0, we can actually kind of iterate on this preview that we get. And what V0 is going to do for us is basically going to write all the code that we need, okay? And what we can do once it finishes up is we can actually just copy that code over to our app. So I'll show you how you can do that. This is a really awesome tool to use. I highly recommend it. If you're somebody who uses writes code professionally or is building these tools a ton, I believe V0 Pro is like $20 a month. This isn't sponsored or anything. It's one of those tools that I do personally use myself, and I think that it's gotten so good that I think it's one of those, like, if this is what you do professionally or you're adjacent to it, I think it's worth paying for. I think you're going to get a ton of value. As you can see here, we basically have the two components that we need to actually use in our app, right? So like one of the things that I want is I want this to take up the same height as chat. So all I have to do in V0 here is ask, right? I can just say, please make document upload the full height of the page, just like chat. Okay, we want this to come all the way down. If you saw the example app that, the reference app, which again, you can check that code out. Both of those are taking up that full height. So we can just continue to iterate on that. If we wanted to iterate on that manually, of course, we could have just copied the code. But what I'm going to do here is we're going to just copy this over just so I can kind of show you how to use that within the app, right? So what are the things that we could do here as the preview kind of loads up here? Okay, so now this is the full page, right? We could go over to this code tab up here, and it looks like it made us 2 of these. I'm going to guess that the one we want to use is this one. That's kind of funny. That's probably like a little bit of a bug. But you can download the file. You can copy it. So in this case, we'll just copy this code and we'll paste that right into our document uploader component here. And then, of course, to use the uploader here, what we'll need to do is we'll need to go into our page.tsx. We're going to get rid of all of that boilerplate code. Again, not just the page code here that's rendering sort of this starter template code. And what we need to do is we'll wrap this in a div here, and we'll use that document upload. Okay. And then if we go back over to localhost 3000 here and refresh this, we should see that document upload component. And one of the things you might be wondering is, why is this the layout? Well, what we can do is we can bounce back over to v0. Okay, we can go over to that page. Okay, and what we'll do here is we'll actually copy the code. Okay, we're going to copy this code from page, and we'll just replace our page code with this code, right? And of course, the imports are going to be slightly different here in our app. So what we need to do, we also need to go make sure to grab that AI chat code. Okay, so let's copy that, put it in AI chat so we have that code as well. And let's get our import right. And then if we bounce back over to localhost 3000, you'll see we have this beautiful code that v0 has generated for us. We were able to just work right in the chat interface and get these like pretty solid starting components. Of course, you know, if you want to go into this code, right, the nice thing is you own the code at this point, right? So you can go in, you can tweak styles, things like that. But the point here is that this is a really nice way to build out your UI, and we wanted to just kind of sneak this little trick. I know the focus of this course is RAG and retrieval and building that, but one of the things that you're going to need to do quite often as you build RAG tools, retrieval tools, is you need to actually build UIs for it. And v0 is a super helpful way if you're not, if you're not a front end developer, things like that. You're just, maybe you're a business analyst trying to use Cursor to spin up a quick RAG tool or something, and all these AI tools are allowing you to do this for the first time. Well, v0 is kind of your front end developer companion in a lot of different ways. So one of the things that we're going to do just to keep things consistent between the reference app and our app is we're actually, now that we've showed you how to do this on your own, we're just going to go ahead and copy the existing code that we have just to keep things simple here. So we're going to go into that reference app and we're going to grab the page code. So I'm going to copy the page code from the reference app over to the MyRag app page. Okay, and you can see it's pretty similar, right? The only thing that's changing is like a few styles, and then we'll close that up, and then we'll go to the reference app's two components, the AI chat one and the document uploader. Okay, so let's go ahead, copy those over to our files. Okay, so we're just going to copy and paste that entire file. We're going to replace everything that is in there with what we have here. Okay, so I'm going to grab the reference document uploader and replace that in our app document uploader. And what you should have, looks like I have a slight import error. We may have named this something else. Let's go check that out. Okay, so in our lib folder, in rag in generate, lib rag generate. Okay, so we called this generate instead of generation. Boom. Okay, got rid of that error. Now, if we go back over to localhost, you can see more or less looks the same, but what we have now is we actually have our RAG system connected to this UI. So what we need to do now is I actually need to explain how this got hooked up so that you actually have some context on what is going on there. Okay, so what we'll do, let me just close a couple of these files just to simplify things just a bit. Okay, so at a high level here, we have our page. Okay, this is just our top level page with the document uploader here on the left and our AI chat component on the right. Okay, simple enough. Then next on the left here, we have our document uploader. Okay, so what are the pieces that we have here? Well, we have a giant text area here. Again, you'll remember earlier we we installed the button, the input, and the text area components from shadcn. Okay, so what our component here is doing is it's just importing those components that we got from the shadcn library. Okay, again, really nice way to just get free code out of the box. So this is one of the reasons why it's so popular, right? So you have a little bit of a heading here. We have that text area. Okay, so this is as we work with our text. If you want to, say you have a giant Word document or something, you paste that in here, hit the upload button, and what you'll see here is this upload button calls this handle upload function. So what does the handle upload function do? Well, it takes whatever text is in our text area, it runs that into our process document function here. Okay, so you remember this is our RAG pipeline for actually getting the text that we enter into the document uploader embedded, chunked, and inserted into the database. Okay, so we're going to test that here in the next lesson, but I just kind of want to talk about what's going on here beforehand. Okay, so document uploader, you paste your text into here. So what we could even do is I could say, hi, my name is McKay. Okay, So this is going to take this text, and when we hit upload document, this is going to run, it's going to chunk it. So in this case, right, this is obviously going to be less than 500 tokens, so it doesn't really need to chunk anything. It's just going to be a single chunk. It's going to embed that, and then it is going to upload that to our database. And the way you can test if that worked was if you go to your database here, and I'm actually just going to need to refresh this, you'll see after I hit that button, we now have, hi, my name is McKay. We have the embedding. Okay, everything is set up for the retrieval process. Okay, and the retrieval process is handled by the right side here. That's handled by the AI chat area. So let's jump into that component here, talk a little bit about what is going on there. So one of the things that we're doing, okay, we're keeping track of our messages, our input here. Okay, this is all just like front end state stuff. If you want to learn more about that in detail, we have our app building course that you can go take that kind of teaches you all the ins and outs of all this stuff. But because we kind of have those reference materials, I won't make this a full lecture on front end development. We'll keep things pretty light here. But what we can do here is we can actually send the message here. So what happens here, right? If I say what is my name, what's happening here is that value is getting tracked on this input here, and when we actually click this send button, so if I go back down here, you'll see we have a button at the very bottom here. Okay, you can see there's that send text, and you can see that when this button is clicked, it is running this handle send message function. So what does the handle send message function do? So at a very high level here, the very first thing that we're going to do is we're actually going to run our RAG pipeline based on our input. Okay, so we're going to take this what is my name, I'll even do a question mark, what is my name, and then we hit send. That is going to get passed to this handle send message function, and it is going to run our RAG pipeline with that input. Okay, and as you can recall, our RAG pipeline consists of 3 steps. First, we're going to take this text right here, we're going to optimize that query. Okay, so it's going to run the query optimization. The next step is we are going to pass in the optimized query to our retrieve documents function, and we're going to fetch the 25 most similar records with a minimum similarity score of 0.2. Okay, in this case, we only have 1 record in the database at this point, so it's only going to fetch 1. But what's going to happen after that is we're going to take those retrieve documents and the optimized query, and we're going to run our documents through Cohere's Rerank API. And at that point, we will get from the most similar to the least similar, the 5 most similar documents here, and we're going to return those. And if we pop back into our component here, you'll see that gets set as relevant docs. And once we have those relevant docs, again, relevant docs are just the final output of our RAG pipeline, we can pass that in as context to that generate completion with context function that we wrote a couple lessons ago, right? And so what's going to happen is the context from those 5 sources are going to get inserted right here. And so what happens is the AI model, in this case GPT-4o Mini, it gets a system prompt that says answer based on the provided context with whatever the context is of those 5 most relevant documents with our input. So in this case, it will be what is my name. And then if we send that off, you're going to see we get a nice little UI that shows those sources here. So if I actually click that button and open this up, you'll see number 1. Again, we only have 1 source right now. Hi, my name is McKay. And then you can see in blue here, the AI answers, your name is McKay. Okay, so that's our RAG pipeline working with these 2 components here built fully out. So we're going to go ahead and actually take a look now at a little bit more of an advanced example. So like to prove that this works, one of the things that I'm going to do here is we can grab, so this is the Wikipedia entry for the 2024 United States election. Only reason I'm using this example is because this is a fairly recent event, right? That's not going to be in the training data of an LLM, right? It's the model's going to have been trained a couple of months ago, so it won't actually know who won the election. What we could do here is we could copy and paste this entire Wikipedia entry here. Okay, you can see, I chose this one just because it's a current event that has a really long Wikipedia entry. We're not going to get political here, of course, but it's just a good example for RAG, of course. What we can do is we can actually paste that in, and you'll see we have this giant page, right? This is the entire Wikipedia page. in our text box here. And obviously this is going to be a super long text document, right? This thing is going to need to be chunked. And one of the cool tools you can use is actually this OpenAI tokenizer. They have a really cool example here on the OpenAI website. So if we actually paste that text also into the tokenizer here, you'll see that this text is 37,514 tokens. So that means this is going to get split up into a bunch of chunks. So what we can do here is if we hit upload document, this is going to run that document uploader function that it's going to process the document. And if we go to our RAG database here, what we'll do is let me just give this a good old refresh here. What you'll see here is we now have all of these chunks, right? And so what happened is because that Wikipedia page was so many tokens, it had to run our text splitter, had to split things into a bunch of 500 token chunks to kind of split that thing up a bit. You can see we got a total of 76 records plus our one from the example there. And what's cool about this is it generated an embedding for each one of these. And now what we can do, is if we say, let's see if we can find something that's like really niche in here. Let's say, what did Eric Cortellessa write? Okay. Let's actually reset. So we have a little reset button to reset the chat. What did this individual say? And let's see how good our RAG pipeline is. Let's hit send. Okay, and you can see we have the 5 sources, so we can kind of hide those. And you can see this is literally pulling out the exact passage basically from the Wikipedia page. Okay, so it was able to run our query optimization, then our basic retrieval, and then our document re-ranking to give us these 5 sources. Okay, remember each one of these is going to be 500 tokens because of how we chunk things up. Okay, so we're using these 5 sources as context, sending that to the AI model, and it's generating an answer. And as you can see, we use something that was like very, very minute, a little tiny detail in here. And it actually got it right, which is pretty impressive. Like if we tried one other thing here, we could say, let's go up here. Well, let's do something very basic. Let's say what was the electoral count? What was the electoral count? Right, that's a pretty standard query that people are going to want to ask. Okay, and you can see I'm not using election, I'm not referencing the document, right? It's just going ahead, finding the results in here, which you can see this is the most relevant one, which it appears to be pulling that electoral votes, and you can see it went 312 and 226. Let's verify that that's correct. I'm guessing that's going to be pretty high up here. 312 to 226. Okay, very interesting. So you can see our RAG pipeline is working exactly as we want, right? We're taking something that's really long, a 37,000 token text document. We're uploading that, we're processing that into that document so that we're getting it embedded into our vector database, and then we're able to successfully rank the most relevant documents and actually get the pieces of information that we want, right? So let's get away from politics. How about again, we're just using that because it's a current event that has a really long Wikipedia entry. Let's do something like let's get the Mars Wikipedia page in here. Something a little bit more something a little less explosive. And we could copy this. I just want to do one more example just because it can demonstrate how you can really start to separate things, right? So let's grab that entire entry. Let's upload that. Going to take a sec here to run. If we go into our database, again, we can refresh this. We should see a lot more records. Okay, so it looks like we got about 30 more records or so. What we could do is, okay, let's find a little fact in here. Let's say, what are the environmental conditions on Mars? Let's say, does Mars have, how much heat transfer does Mars surface have? Let's reset this. How much heat transfer does Mars surface have? So we would probably expect the answer to get us something to do with this passage here. So let's go ahead and see if it can do that. You can see Mars has little heat transfer across its surface due to its thin atmosphere. And you can see, lost my place here. The planet has a little heat transfer across its surface. You can see it's talking about atmospheric pressure here. Okay, so it basically was able to go and through how many records do we have? 104 records here. Okay, again, we have like that entire election thing. We have this test record I put in. We have the Mars database, right? And it's still able to grab the most relevant results and give us the answer that we were looking for, okay? So this is a great example of a real-world RAG pipeline. Anytime that you build retrieval tools, this is like the absolute foundation that you're going to be working with. Again, there's going to be some different things, like, one of the things that you're going to want to try out, and I kind of left this for you as a stretch goal, because I think this is how you really learn, right, is for a lot of document uploader stuff, you're not going to want to copy and paste text. You're going to want to, like, grab a Google document or something, download it, and maybe upload it to some sort of a file uploader instead of having to copy and paste, right? And so learning how to do that and taking all of the principles that we've kind of talked about and just learning how to do things like use different document loaders. Maybe you want to split things semantically instead of by token count. These are some of the kind of the use case dependent variables that you're going to want to get used to. But the reason we kind of constructed the project the way we did was because the way we do it here is going to be the kind of level one, the base layer, the thing that you can take between every single project and you can use anywhere you want. And, all that other little stuff, that's going to be a use case dependent stuff. So we kind of tackled the absolute core of a retrieval tool, right? It's going to be some way to upload a document, get that into a vector database, some way to actually use, an AI chat interface or some sort of query mechanism so that you can actually run a RAG pipeline, get the most relevant results, send that off to an AI model, and get the result that you want. Okay, so hopefully you can take everything that you learned here in this section to actually go build your own apps, your own tools, so that you can use retrieval and RAG in all the different ways that are going to be helpful to you. So I hope you found that helpful. That is the completed project. Again, I do recommend, if you have the time, try a couple of stretch goals. Try doing PDFs. Try instead of chunking by token count, try doing it based on new lines, new paragraphs, things like that. So I hope everyone found that helpful.